Picking up an item when we get near it is not an ideal way of putting things together. We want the character to choose what they obtain in their game. It especially doesn't work if you gave your character the ability to spawn items back in the world when dropping them, because if it spawns next to us and we immediately pick it back up again, not only is that inefficient, but it can create bugs. So the new way we'll do it is we'll have a small prompt that shows you can pick an item up, and when we get close, it shows you how to pick it up. And that'll be with a little arrow icon and an E icon, because we'll set our button to E. So we have two icons to import. So open up our textures, inventory. Actually, let's just put this in textures. It's not really an inventory. So let's say import, and it'll go to my resources. It's the arrow prompt and the E prompt. We'll open them, and we will bulk edit via property matrix for both of them. Compression settings will be user interface 2D, and our texture group will be UI, as always. And file, save, and close this. And we need a new widget for these. So let's go to our UMG. We can put it in inventory, and we will create a new widget blueprint. Let's call this W pick up prompt. I'm gonna make that U capitalized. And that crashed my engine, because it does not like capitalized U's. Alright, now that I've got my engine started back up, let's go into blueprints, or UMG, inventory, and open. Oh, it does not exist anymore, so let's create it again. W pick up prompt, and we can open this up. And we want to make this desired on screen, and we don't want a canvas panel. We just want a size box, and we want the size to be 500 by 500. So let's add an image here, and we will call this image prompt image, and by default we'll make it that arrow. Arrow prompt. There we go. Before we continue in here, let's put it in our pickup item to see how it looks. So let's go to content, blueprints, actors, inventory, pickup actors, and pickup actor master. So let's add a widget component. Just type in widget, and I guess we can rename this prompt widget. And just to see it better, we can pull it up. There's nothing in it right now, but we can change the widget class here to pickup prompt. And this is obviously way too big, and we need to scale it down. Now we need to use the actual scale here and not the draw size. As you can see, if I change the draw size to something like 25 by 25, or let's do something slightly bigger, 50 by 50, and we zoom in, we've got this really jagged looking look. Instead, we need to leave this draw size to 500 by 500 and mess with the scale. 0.01 is much too small, 0.1, and now we can see it is nice and sharp. And compile and save, and we can see in our world they are now above all our items. They're quite big, so I'm going to change this size to a default of 0.03 on all axes, and that looks better, even though they're way too offset. You might be able to hear my cat jumping around. She's making a lot of noise right now. Anyways, let's go back into our pickup actor master. By default, I'm going to make this sphere once again hidden in game, and by default I'm going to turn off physics so it only simulates physics after we drop the item. Alright, so we want this arrow that points at our objects to turn into the ePrompt image when we're close enough to pick it up, but we want to see the arrow at quite a far distance, so we know there's something over in that area that we can pick up. So in our pickup actor master, we want to set this default visibility to false. We want to do this visible here, not the window visibility. And you'll see in the game they have disappeared. And we also want to change the default extent of this sphere to something more like 500 instead of 100. So something quite big. Now we want to move this character spawn point, because spawning inside an overlap sphere when we're told to do something, that can create bugs sometimes. So I'm just going to move him back. If you hold shift while moving an object, the camera moves with it, so I'm going to just move it outside the spheres. So we start over here now. And what I want is when we enter the big sphere, we see the arrow prompt, and when we get close enough to be able to actually pick the item up, it'll turn into the E prompt, and we will be able to pick up our item. So in our pickup actor master, we want to create a boolean called update actor, and we can make it private. So we don't want to add our item when we overlap the sphere anymore. So we can break this off, and we're just gonna move all of this down. So I'm just gonna break that as well. And we're just gonna move this out of the way for now. When we overlap the sphere, I want to set our update actor to true. But before that, I want to set the visibility for our prompt widget to true as well. And we can create an end overlap on the sphere. And we can, let's bring it up here, move this a little farther down. And this will also be casting to the L1 character. And once we end the overlap with the sphere, let's set the visibility of the prompt widget back to hidden, and we no longer want to be updating our actor. So we can actually test that out now by, we'll have to kind of go to the other side so we can see them. So we're overlapping all four, so we can see all four. And if we kind of back up, they disappear once we leave the sphere. It's exactly what we want. But we need to make sure the widget is always facing us, so we can always see it from any angle. So we'll do this with an event tick. Keep moving that down. We'll create an event tick. And we only want it to update if we're updating the actor. That's why we created this variable here. So only if we're inside the sphere, will it worry about updating the widget. So if it's true, we can get this prompt widget, and we can set the world rotation. And out of new rotation, we will get a find look at rotation. For the start location, we just want our prompt widget location, so get a prompt widget. Oh, that was my cat again. Get world location. Put that into the start. The target will be our character. So we need a reference variable for that. So we can make it in the begin overlap, since we're already casting. So we can promote this to a variable. Player ref. And plug it in right there. And we can make it private so we can access it from the children. We're getting an error because we didn't plug anything into the target, but we're doing that now. So we just have to get the player ref and then get the camera. We always want it to be facing the camera, not quite our player. And get world location. And plug that into target. So now we can test that out by hitting play. And once we enter these spheres, the widget will always rotate to face the camera. So already a good sign that we can see it when we're coming in. And as we walk around, they are always facing the camera, even on when we're below it, which we won't be soon. I understand that they're way too high at the moment. But it's good because now they always face our camera. So it looks great, but we don't want to be able to see this through walls and doors. For example, if I just bring one of these doors over and I duplicate it like this, and we go in, we can see all these. Problem is we can still see it through this door, or it's still visible, and I don't want that. So we'll do this with a line trace. So in our pickup actor, before we update the rotation, just pull this out, we want to add a line trace. And just kind of move this out of the way. We didn't pull these out far enough. And there we go. Pull this down just a bit more. Okay. The start will be the get actor, just our get actor location. It's not the correct node. Get actor location. And the end will be our player's location. So let's get our player ref, or our player's camera location. Get the camera. And get the world location. And we'll plug that into the end. And if we draw the debug type to persistent, we get kind of a cool effect going on here if we hit play. So once we're inside the overlap spheres, we'll get these line traces that go from the actor to our camera. I did not mean to make this persistent. I meant to make it for one frame. Makes it much clearer what's happening. Go in, and it's kind of hard to see actually because there's a camera, but if we move around, we can see these lines always pointing at us. It's definitely easier to see if we just get the player ref's location, or we can get the player ref's actor location. Oops. And that makes it easier to see what's going on because it's not going right into the camera. So we always have these lines going from the actor to us. And basically what we're checking is if these actors collide with something, which these three are, we don't want to be able to see those three widgets. So we can change this back to our camera, delete that. And we just want to create a branch from the off hit here. But we want to only update it if it didn't hit something. So we will add a not boolean instead of just taking it from the false. So now we can take it from the true and continue right there. If it's true, we want to set the prompt widget's visibility to true. Actually, I shouldn't have brought this back forward. Set this to true. And if it's false, we want to set the visibility to false. So we can test it out with the door now. And we can go inside here. We can see all of these. We stay inside, but we go behind this door. We can no longer see those widgets, even though we're still inside the reference. And those little red squares are these line traces because we still have it on for one frame. So let's turn this back to none for the debug type. Not only is this for just visibility purposes, but it's also important so we won't be able to pick up items through a wall. Even if we're close enough to pick up an item, if there's anything in between us and the item, we will not be able to pick it up. So we can go back to our widget pickup prompt, and we can go to the graph, and delete these. We can create a custom event, toggle prompt, and we have to give it a Boolean input, and we'll call it can pick up. And we'll just get our image and set the brush from a texture. And we want to match size. And we'll get a select node from the texture. Input will be the index. If we can pick it up, or if we can't pick it up, we want it to be the arrow prompt, which is the one it already is. And if we can pick it up, we want it to be the E prompt, which is this one right here. But by default, let's keep this at the arrow. So for true, we can just set this to E prompt. So let's go back into pickup actor, and we want to create a variable. We're going to want to call this pickup distance, and this will be a float. And the default distance for picking up an item could be 150. We can make this editable, so it's easy to change in the editor. And in our line trace here, we can just break the out hint. And let's open it up. And we just have to, once again, move this down. But we just have to subtract the trace start from the trace end to see how long the length is, because this one's always changing. And if this length, get vector length right here, and if the length is less than or equal to the pickup distance, we want to toggle the pickup prompt. So to do that, after we set the world rotation, we can just get our prompt widget, and we'll have to get user widget object, and then we can use this to cast to our W pickup prompt, and we can convert that to a pure cast, and we can just call this custom event toggle prompt. And the can pick up just comes from this little bit of math right here. So we can actually test to see if this works. So let's go down and save. Let's hit play. And I guess before we get started, let's bring the widget down. It's very up high. What's it at right now? 210. Let's just put it at something like 80 for now. Let's see what that looks like. Okay, yeah, that's fine for now. So once we are less than 150 units away, it turns into the E. Perfect. This is also something we can edit for each specific actor just by adjusting this pickup distance. Adjusting it here in the world will adjust it just for the one singular actor, or you could open it up in here and mess with it in here so that it'll affect all of these. So back in pickup master actor, after we toggle the prompt, we have to add a branch, and the condition is the same condition. And if it's true, we want to enable input. We want to be able to call input from this actor. So the player controller will be get player controller, and the target is self. If it is false, we want to disable input. So it only accepts input once we're close enough to pick up our item. What we also want to do is off this false here, if there's something in the way of us being able to pick up the object, we also want to disable our input here. So we'll call disable input, and the target is our player controller. And just as a safety, we can also call disable input once we end overlap our sphere. So disable input, get player controller, and that'll be that. Alright, so now that we can call input once we're close enough to it, we can just add a input action. Remember, this is something we set a while ago. It's bound to our E key. And to test, we can just print a string, and we will say this as pick up item. So let's test it out. In our world, we're not close to any items yet. We press E, and nothing happens. We get close enough to these where the arrow prompts come up. We press E, and nothing happens. but we get close enough to where this gives us the E prompt, and we press E, it says we can now pick up our item. Same over here. So instead of calling the print string to pick up an item, we can just replace that code with our add item right here. For the target for our PPC inventory, we can just use our player reference. So now, when we press play, and we come up close to this, and we press E, item disappears because it has been added to our inventory. And we can do that with all of them. Great. Now there's a couple issues here, and one is when we drop an item, the widget stays up there. Does not look good, it's not what we want. We want it to be stuck to our item. Another issue is every single item has the same distance between the mesh and the widget, and we want that to be adjustable. So in our pickup actor master, we can create a new float called widget distance above mesh. And we'll make that editable as well. Compile. And the default can be something like 25. And in our construction script, we just want to get this prompt widget. And we just want to set relative location, split the location, and we just want to set the Z to widget distance above mesh. This will update it to being only 25 above our mesh, and in-game that looks like this for the batteries. It looks great for the batteries, but obviously not good for this giant sphere door key. So on the door key in the world, since we made it editable, we can adjust it directly in here. Oh, I think we'll have to... Right, we can't see it in the world, so we could go in and kind of mess with it to see it back in the world, but... Or you could just play the guessing game. Let's try something like 50. And it needs a bit more, so let's do 75. I think 75 looks pretty good. So we can actually just open the BP actor door key, and we can set it to 75 in here so that every door key will be 75 and not just the specific one. Great, so now we've figured out our problem for how far above our icons should be of our mesh. But we also need them to fall with our mesh when we simulate physics. So let's go into our pickup actor master, and in the event tick, before we even update the actor, we want to set the prompt widget's relative location. Set relative location. I'm sorry, not set relative location. This time we want it world. Set world, not offset. Third time's the charm. Set world location. Plug that in there. Then we want to get the static mesh and get its world location. And let's split both of these here. The X and Y can just stay as X and Y. And for Z, we just need to add the widget distance above mesh. And now we can compile and save. And when we pick up these flashlight batteries and we drop them into the world, the widget drops with them. We can also test it by dropping it kind of into the wall here to make it bounce around a bit. And it still just stays above our mesh. And the last issue we have is when these are simulating physics. An issue we have is, especially with ones that are small like this, when walking over them, these small items can be pushed through the ground and or make your character kind of spasm a bit. If we can test it out a bit. Well, it's when we just kicked it very far. Yeah, that was a bit of a character spasm. Same with that one. and sometimes they'll just be pushed through the earth. And it can create some issues. Yeah, that does not look good or professional. We don't want our player to be able to collide with these objects, so we can go into the master pickup item and get the static mesh and change the collision presets here to custom instead of block all dynamic. And we want to set the pawn here to ignore so that it interacts with everything else except our player. So now we can hit play, we can pick these up, and we can drop them. Now when I walk over them, we no longer interact with them. It interacts with the world, it interacts with everything else except for our player. Alright, so that is it for improving item pickup. Let's add some information to our inventory items by displaying their names and descriptions. We need to go into our item data struct. So let's go into content, blueprints, structs, item data. And I'm just going to close everything else for now. We'll reopen it as this episode goes on. Let's pull this down. And we need to add a description variable because we already have our item name. We can make this of type text, and I'm going to use this up arrow to bring it towards the top, and I'll leave it third right there under the icon. So let's go into our master inventory item and compile it. So our children now are updated, and we can now add a description. So let's give it something like, add it to your flashlight to replenish your battery life. And let's open the door key as well, and we'll say use this to open a locked door. Alright, so let's open we can close these, and let's open our inventory menu. So let's go into UMG, inventory menu, and we want to add a section for the name and description. So let's add a vertical box. Just drag this in here. It's a vertical box, so it can contain the name on the top and the description on the bottom. So we're going to have to kind of resize this. A size I like is 560 by 330. And I'm going to put it on the right side here. So let's anchor it to the middle right. I'm going to position X and Y to 0. I want our X-axis alignment to be 1, and our Y-axis alignment to be 0.5. So it's right in the center there. And let's bring this up here. And I want to bring it a bit away from the full edge, so I'll make the position X -50. There we go. So let's add a size box for our name, and we can check the height override and give it something like 50. This is where our name will go. And we can add text to that size box, and we can call the text item name text and set it as a variable. And here, as default, we can just say item name, and we can center it on both. Make it our font, and we'll make this, let's see, we'll make it default. Let's also remember to remove the shadow offset to center it in a bit. And you can align it to the center. I actually think I want to align it to the left. I'm going to have both of these aligned to the left, so it's a bit closer to our inventory. We can also make kind of this little white line between the name and the description. So I'll do that with an image that I just created real quick that you can import. So let's go into textures, and we can just drag in our image, which is this separator image, and it's just this gradient I made. And let's open it up, and we want to change As always, the compression settings to user interface 2D. This here is the same settings that it is when we bulk edit via property matrix. It just looks different when we're doing it for multiple than when we're doing it for one. So our compression settings up here, and then our texture group is down here, and we want to set it to UI. So let's hit save and close that. And it's a opacity gradient. So we can add another size box below the item name in our vertical box. And I'm just going to make the height override 5. And we can add an image to this size box. And it fills automatically, but you can double check to make sure it's filled. And the image we want is our separator. And it just kind of creates this white gradient just as a separation for the name and the description. Since it's white, you can also use the tint to make it any color you want. We need to give it just a slight like bluish tint or something like that. And we don't need this image to be a variable, so we can uncheck that. Now for the rest of the vertical box, we can just add our text for our description text. So drag it into our vertical box, and here it is. And we'll rename it to description text, and we'll make it a variable. And we can change our font to our Calibri font, and we can make it light or possibly light italic. We can make it a little smaller, like 20. Remove the shadow offset. And we can give the top just a bit of a padding, just to bring it a little farther down away from the separator, of like 10 maybe. And there we have our text for our description. And we have one issue here, and I'll show you what it is if we click on our text block. And let's give this text something really long, like this is the description for the currently selected, oh, can't see it, selected item. Oh, well, that actually fits. Hooray. As you can see, it goes outside of our vertical box, so we don't want that. We want it to wrap around to the bottom here. So to fix this, we need to scroll down and choose auto wrap text, and this will auto wrap it to our vertical box. Well, if we're going to leave it at this, we could at least give it proper grammar, and there we go. We can see how it wraps around. So we could actually see how this looks in game since we've just added it to our menu. We can hit play and tab, and here we have our item name and our item description. Now, of course, this won't update, and it'll always be showing, and we don't want either of those things. So we can go back to the menu, and we can take this vertical box, and we can actually make it a variable. The entire vertical box that is holding all of this information. And let's rename it to something like item info vertical box. And we can set the default visibility to hidden, so we don't see it by default. Now we can go to the blueprints, and we can make a custom event, and we can call this show item info, and the input we want is item data, and it'll be of type S item data. So we can break this, and now we have the name and the description, and we can just set our name and description to that. So we can get our item name text, and we want to set text, and we'll plug in our name to that. Let's do the same for our description text, and we will set the text. And we can set this directly from our description. After that, we want to make the whole vertical box visible after we update it. So we can get our item info vertical box, and we can set the visibility to non-hit testable self and all children. We don't want to be able to actually click or interact with any of the text. We just want to be able to see them. And we just have to make another custom event for hiding the info. So we'll make a custom event, hide item info, and we just need to set the vertical box visibility to hidden. So now we just need to call these, and I want them to be called whenever we hover over an item slot. So let's go to our blueprints, or not our blueprints, sorry, our UMG inventory slot. And for this button here, we just have to create on hovered and on unhovered. So we'll create one for both. We can click the slot button right here, create an on unhovered. It's the same thing as doing it in our designer. And on hovered, we can just get our inventory menu ref and call show item info. And for item data, we will just get our player ref, get the BPC inventory, get item data at index, and our index is our index variable. And for the item data, we can just get class defaults from their item and plug in our item data. Compile and save. And then on unhovered, we just need to call the hide item info. And now we can test it out. So let's hit play. Let's grab 2 of our items. Let's grab some batteries and some door keys. And now when we hover over the battery, we have our name that says flashlight battery. Add it to your flashlight to replenish your battery life. Unhovering hides it. And when we hover over our door key, it updates to saying door key and uses to open a locked door. Great. So now we have our name and description for the item we're hovering over. You could easily change this to never setting this to hidden, so that we just wouldn't have, you would just make this show item info to updating the info, and you would remove this visibility, you'd remove this custom event, you would change the vertical box in here to visible by default, and you wouldn't need to call hide item info, you would just need to call update item info. And that's how you do it if you didn't want it to disappear. Forgot we have to press E now when you stop hovering. So let's get some actual icons for our item instead of these placeholders. And of course the placeholders I'm talking about are these faces here. We want them to actually look like our items. Take note that using something like Photoshop is very good, if not better, options for creating icons. But since this is a course in Unreal Engine, and I also don't want to expect you to own Photoshop, because it can be expensive, I'm going to show you a way to make icons directly in Unreal Engine. But I would like to reiterate that making them in Photoshop is definitely a very, very good, if not better, option for creating an icon. So let's get started in making them in Unreal Engine. We already have a mesh for our battery that we can use, but not for our door key. So I made a quick door key in Blender real quick that we can import now. So let's go to content and let's go to props, meshes. I'm going to hit import. I'm going to navigate to our door key. I'm just going to, oops, I don't know how that switched right there. Back into content browser. I'm just going to drag this in. And it is not a skeletal mesh. We can auto-generate the collision. Our import transform is fine. And we can create new materials. So let's hit import. And we have this very low poly door key that I created. Now it needs a material. I didn't make one just because I figured it could be a flat material. So I figured we could just make it in Unreal Engine. So let's go to props, materials, and let's make a new material. So right click material. We'll call it M underscore door key. And let's go ahead and add M's before these two as well, just because that's how I like to add prefixes to our materials. So let's open door key, and this can be very simple. We'll just make a color for the base color. So to do that, we hold down our 3 key and we click, and it creates this constant 3 vector. If your 3 key doesn't work, or you have to just want to type it in, you can just right click and search constant and choose constant 3 vector. And that's the way we can create just a color. So we can select a color. I'm just going to choose a dark gray. And I'm going to plug this into base color. It's also a bit too shiny for me, so I'm going to hold down 1, and this will create a constant, which is just a number. Once again, if you just right click and search constant, it's this first one right here. And this constant is going to control our roughness value, which controls how smooth / rough it is, which equates to how reflective or matte it is. So we can plug that into roughness. You can see 0 will make it incredibly shiny, but we want the opposite of that. So I'm going to make it something like 0.9, almost completely rough, and we'll just have this matte gray color for our door key. So we can open our mesh again, and we can just set the material to door key. And now it's this dark gray. So let's take our door key pickup actor, and let's make this actually the key instead of this big old sphere. So we can select our door key right here and click Edit Pickup Actor Door Key. Sometimes it's just a faster way of opening the actor, and we can hit Open Full Blueprint Editor. In our viewport, we can take this sphere, and we can replace the static mesh. Make sure you select the static mesh with our door key. And now we have the door key right here, and it automatically sets our material, so that's all fine. And we can make sure our scale is 1, 1, 1, which is what we want. And now in the world, we can hit play, find our door key. It's a little smaller now. Right, and let's bring this widget closer down to the key. So we can take this variable and we can set it to something like 25, which is the same as the battery. Play again, and that looks better. You can also make the pickup distance just a little farther, like 250. I think that's what we did for the batteries. Oh, it's 200 for those, so we can do 200. It doesn't matter, it's up to you. Yeah, that feels a little better. Alright, so let's actually make our icons now from these 2 examples. So we need a new map for this. So let's go into Content, Maps, and I'm just going to save. And we're going to make a new level, which is the same thing as a map. And we'll call this Icon Map. And we can open it up. Press Save. And it's completely black. We have nothing in our world outliner. There's nothing in this world. No light, no objects. So let's take our door key mesh. Going into props, meshes, door key. Let's just place it in the world. We can't see it at the moment, but let's put the location to 0, 0, 0. Focus by hitting F. That brings our camera to it. And let's also add a camera. So in here in the modes, we can just search for camera. Also drag it out into the world. And let's also make the location 0, 0, 0. So it's right inside the door key. We also have this view right here. It's kind of hard to see because it's black on black, but we're seeing through the camera's view in this right here. To save this view, we can click this little pin preview button right there. So even when we click off of our camera, the view stays here. Just so we can continue to see what the camera's view is, which we will be able to see in a minute because we're going to add some lights. So let's just add a spotlight just to kind of see what we're doing. Let's make it 0, 0, 0, and let's bring it up just slightly, just to shed some light into the scene. And we can take our key, and let's bring it in front of our camera, and not really inside of it. And we'll just give it a value of 50 on the X, so it's more in front of the camera now. Let's also add a post-process volume. And this is the same reason we've been adding it in all the other levels, or just the two levels, the starting and the new one. And it's to fix the exposure. So we can just go into exposure, change the min and max brightness to 1 so there's no extra exposure. And we also want to make sure this is unbound so the bounds of the box are obsolete. So check that, and you can already see in the camera view it became a lot dimmer and not so washed out. So we're going to be creating a basic 3-point lighting setup, which is just one of the most basic ways to light something that works really well. It has 2 lights in the front and 1 in the back, all with varying intensities, and this just gives a good full light around our object. So we're going to make this spotlight our first light. So let's give it a position of -100, -100 again, and on the Z, 100. So it's over here in the left and behind our camera. We also have to rotate it 45 degrees to face our mesh. So we can take our Y and we'll make it -45. And we need to rotate it also on the Z 45. So we'll just 45 on the Z. And now it is facing our key. The intensity is a little low though, as we can see. So we can change it to something like 25. And now it's lighting up our key quite nicely. So let's add the other 2 lights for our 3-point lighting setup. So let's create our second light. Well, I'm Alt and dragging the spotlight to duplicate it. And this is going to be the same as this, but on the right side. So we'll change this from -100 to just 100. And it needs to rotate 45 degrees this way. So we'll give it a Z of -45. Cool. And we don't want this one to be as bright as our main light. There's what's called the 150-20 rule, which is definitely a flexible rule, and people like to use different values, but what works really well for this 3-point light system is having your main light, which is called your key light, to have 100% of the intensity, and then your fill light, which is the other one in front but dimmer, to be 50% of that intensity. So we can change this one to 12.5, and the back one to be 20% of that intensity, which would be 5. I may or may not have pulled out a calculator, but don't tell anyone. So let's add our third light by holding down Alt and pulling out this front light. And we want to, instead of having this -100 on the X, just 100. So now we can actually go into top view. It might make it kind of easier to see what we're doing. We need to rotate this 135 degrees this way, or just 90-degree offset, as you can see right there, 90 degrees. It's 135 on the Z. And now it's facing our key as well. And this needs to be 20% of the intensity of the key light, which will be 5. But to be completely sure, these little number inputs actually can handle math, so you can multiply it by 0.2 for 20%, and you get 5. So we can take our camera now, and we can right-click, and we can set Snap View to Object. So now our full camera is actually getting the view that our camera actor is. And we can unpin this and click away so it kind of gets out of our way. We are now looking through the eyes of our camera. And we can adjust our mesh to kind of see how we want it to be rotated from our camera's view. So we could do it 90 this way and maybe have like a 45-degree tilt. I know that's 50 degrees, so we'll come in here and fix it. So it's 90. This would be -45, and this is 270. Or I could just change this rotation grid snap value from 10 to 5. And I kind of like this rotation here. Don't be afraid to just pull away from the camera. It will not move the camera with you. It's just setting our current camera to this view. And once we get a positioning of the mesh that we like, we can actually change our camera view from perspective to orthographic. Orthographic cameras, unlike perspective cameras, the distance does not actually make a difference in the camera view. Everything that the camera sees is essentially taken in as the same distance away. So if I were to duplicate this by holding down Alt, and I can just move it a little to the right, you can see, even though this one is behind this one, the camera sees them at the same scale. The scale is not affected by the distance. So I'm going to just go ahead and delete this one. And this gives us much more of an icon look. So now we need to take this mesh and we need to search for custom depth pass. And we want to render custom depth pass. This using this, we can export an image only containing this mesh and nothing else in the world. And while nothing else is in the world, this is to eliminate all the black behind it, so we get a nice transparent image. And one last thing I want to point out about orthographic cameras that I realized I did not mention is if the key seems a little far away, when you first change it to orthographic, I think the default ortho width is 512, and you can see it's pretty far away. You just need to adjust this to pull it in accordingly. So I went with a value of 40. So the way we do this is we actually take the screenshot with our viewport camera, not with this camera right here. This camera here is only to kind of figure out positioning. It was to show you the orthographic versus perspective and the rotation of our key. But we take it with our viewport. Now, one of the issues is we don't actually have a orthographic option for our viewport camera. We can set the field of view, but we cannot change it to orthographic. So the closest we can get to this is changing the field of view from 90 to 5. It doesn't let us go below 5. 0 would be preferable, but 5 is as low as we can get. And this gets us very, very close to an orthographic view. So let's change this back to 90 for now. And let's right click on this and snap view to object. So now we are looking at the key. Let's set the field of view all the way down to 5. And we'll obviously need to zoom out a bit. And we get this blue because this is the camera we're looking at right here. So let's hide the camera in our world outliner. And let's zoom out one more time, just enough to fit the screen. So once you have it all inside the viewport, we need to take a screenshot. So let's go here again, and there's this option here called high resolution screenshot. We can click on it. And first we have this screenshot size multiplier. Putting this up will give us higher resolution, so let's put it up to 3. And we need to choose use custom depth as mask. So it'll only take screenshots of things with custom depth enabled, one of which is our key here. And then we can press this little button right here, take a screenshot. And we'll get this. You can click on the link, and it'll take you to the file location where your screenshot was taken. So you can open that, and we now have this screenshot of our key. And we can close that. So we can go ahead and rename that key icon. And we can do the same for our battery. Close that. Before we move on to the battery, I want to show you a couple more options you have. This one is a lit view, and you can change the lit to unlit for a more flat shaded. As you can see, all the shadows have been removed. It doesn't make a huge difference because this is already a flat colored key, but you could just do this and take a screenshot like that. So high resolution screenshot, 3, use custom depth mask, take a screenshot, and now you have, I opened the wrong one. And now you have this flat shaded one. I'm gonna go ahead and delete it. Okay, so let's switch this out for the battery. I'm gonna change it back to lit, and we can select our battery in our content, our battery mesh, and then select our door key, and we can just right click and replace selected actors with battery. It'll be whatever you have select in your content browser. So our battery is not rotated correctly. I'm just going to put this to 0, 0, and 0. And then we can rotate this 45 degrees. And that looks good. See if we can zoom in once, twice. Okay, just once. And we can just do the same thing. Select it, search for custom depth pass, select that, and high resolution screenshot. Let's change this once again to 3. Use custom depth as mask, and take a screenshot. Open this up, and we have our battery icon right here. We'll call this battery icon. Close that. Now, oh wow, I've opened this many times. But they aren't quite sized correctly. We don't want this kind of 1920 by 1080 or whatever it is. So I'm going to resize them in GIMP. You can, of course, do this in Photoshop. I'm only using GIMP because GIMP is free, and I'm sure not everybody has Photoshop. So if you don't have GIMP, you can just go ahead and download it or follow along in Photoshop. So once you have GIMP open, I'm just going to drag in one of my images right here. And we can zoom out by holding Control and using the mouse wheel. We can also scroll side to side while holding Shift with the mouse wheel. And first thing we want to do is resize the canvas, because we want it square shaped, and we also want it a lot smaller. So let's go to Image up here, Canvas Size. And as you can see, the image is very big because we set our resolution to 3 times. So I'm just going to set the width and height to 512 by 512. So it's a box. And kind of drag the image over here, just kind of center it a bit. And we can go ahead and hit resize. Now we need to scale the image to fit the box. So we can take our scale tool right here on the upper left. And we can just start dragging. And if just clicking and dragging will scale it accordingly. If you hold down the Shift button, it will freely scale, but we don't want that. So we can just release Shift and scale and drag. And it doesn't matter what you drag this to, because we just want to mess with it up here. Sorry about that, my GIMP crashed real quick, so I just reopened it and changed the canvas size, got the scale tool, and selected my battery again. I just need to set the smaller number to 512, and because this icon is set to the lock, this is the unlock, this is the lock, it will size the width accordingly. So I can set my height to 512, and it automatically sets my width to 826, which keeps the correct aspects. And I can hit scale, and then I just need to center it to my canvas. So to do that, I can hit the Q button on my keyboard, or hit this little icon called the alignment tool. And this brings up this on the left side. We just need to select our image, and then hit the align to the center vertically and align to the center horizontally. And it automatically plops it right in the center. So we're just gonna hit File, Export As, and find the area you'd like to export to. This is the original battery icon. I'm just gonna export it in my resources folder. Just ignore this key icon there. And I'll hit Export. And we can leave all these default values as they are. We don't need to change any of them. And just hit Export again. So now we've exported this battery icon, and we can open it up, and we can see the dimensions there. It says 512 by 512. We can't really tell when we open it up in the Windows Photos, but we now have a 512 by 512 box of our battery. Now we need to do the same for our key. We can reuse the same file if you want. It'll be safer, obviously, to make projects for each one. But I'm just going to use this one because I already have this 512 by 512 box. Drag in the door key. It's much too big, of course. So we will grab the scale tool right here. We can select it, change the height to 512. That'll alter both, and hit scale. And then hit the Q button on your keyboard select the door key and choose both of these, align horizontally and align vertically. For me, I feel like this is just offset just a bit to the right, so we can adjust it manually. I'm just going to grab it with the move tool and move it to the left until I feel like it looks good. So now we can hit File, Export As, choose our location, export, change the name to key icon. Try that again, key icon, and hit export, and leave the default values, export again, and now we have our key icon as well in a 512 by 512 box. So let's go ahead and close GIMP. You can save if you want. I've already done this a few times, so I'm just going to discard the changes, and I can close that as well. Let's go into Content, Maps, and let's reopen our level 1 map. Save. And we need to change our camera field of view back to 90, which is the normal. Right, everything looks good. And let's re-import this. So we can go into Textures, Inventory, and I'm going to create a new folder called Item Icons. And in there, import, grabbing these two, dragging them in. We can open it up and see how they look. And they look great, so we can hit Save All. Yeah, that looks good. And we can close them. And then let's go into our blueprints, actors, inventory, and we can open each one of our items and we can change the icons to the correct icons. So this is our battery. So we'll choose battery icon. And door key, we will choose door key. Oh, I think we just called it key, not door key. Yeah. So compile and save. And now if we go into our game and pick up some batteries and pick up some door keys and open this, they are now batteries and door keys. And that looks much, much better than those faces. And we can drop them and use one of them. Great. And that is how you would create icons without the need for Photoshop in Unreal Engine. Alright, so let's move on to our last drop-down menu, which is our examination. This is probably the most difficult part of our 3, which is why I saved it for last. And there's a couple ways of going about item examination. And we're going to use the scene capture method. Basically, what this method does is we have a camera shooting an object that doesn't view anything else in our scene. So the camera will be placed somewhere in our world, our object will be in front of it, and our camera will not pick up anything else. We will create an actor that swaps out the static mesh in front of the camera based on our selected item in our inventory. So, in our inventory folder, which we are already in, but we can go to Content, Blueprints, Actors, Inventory. We want to create a new blueprint class of type Actor, and we want it to be called BP Examination. And this will be the actor that switches out the static mesh based off what item we are examining that we will place in front of our camera. So we can open it up. I'm just going to close everything right here. Okay, and let's add a static mesh, and we can just leave it as static mesh. For default, let's add the door key, just to have something we can view. All right, looks good. So that's all we'll need for now. And let's add a scene capture to our scene. So up here in the Modes tab, under these classes, we can search for Scene Capture, and we want to choose Scene Capture 2D. We'll just drag it into the world, and it looks like a camera. So let's just change this to unlit just for a minute, and let's drag this out just outside of our map so that we never see our BP examination item in the world. Let's now take our BP examination item and put it in the world, And then let's parent it to our scene capture. Then we can set the location to 0, 0, 0, which puts it right in front of the camera, and we can drag it out about 20 units on the X. Might be a little close, we'll do 40. Feels pretty similar to the icon episode so far, doesn't it? So we need to get this view of the key from this camera as a material. So we need to translate the view of this camera, of this key, to a texture target so we can make it a material that we can add to our HUD. So to do that, let's go to Blueprints and let's make a new folder. We'll call it Render Targets, just for a place to store it. And we can select our camera here and scroll down. And here we have this thing called a texture target, which outputs the render target of the scene capture that can be read in materials. Oh, look at that, they misspelled materials, that's funny. Anyway, we need to create a new one, so we can just click on None, and up here we can click Render Target, and we can choose Blueprints, Render Targets, just to choose the folder, and we will call it Examination Render Target 2D. And now it has been created. So we can open this up, and what we are seeing here is kind of an outline. So this outline thing in the middle right here, this is the key, and this is the side of the building. If we go into the world, that's the side of the building we're seeing on the right here. I wanted a bit higher quality, so I'm going to change this from 256 to 512 by 512. Sometimes it needs to refresh itself, so we can close it, reopen it. Yeah, that worked. And as you can see, the lines are a bit sharper now, and you can make it higher quality if you want. I think 512 by 512 is fine. Now, obviously, we don't want to be able to see this building in the background. And we're also going to need some lights for the key over here. So let's deal with the lights first, just so we'll be able to set this to lit and actually be able to see our key. So first thing I think I'm going to do is drag out this scene capture, which will bring our examination item with it, because it's a child, far enough so that the lights we add don't affect our actual scene. We kind of want this to be separate from everything. And I'm going to turn it to face the building, and the only reason I'm doing this is to show in the future when we actually set it to only being able to see the key, just so we can compare kind of side by side. So that looks good. So if we save, this is updated, this little section right here, that's the key, and this is the building. That looks good to me. So let's add that 3-point lighting setup that we did in the icon episode. So we can just get lights, point light, and I'm going to make it a child of the scene capture as well. So I can make it 0, 0, 0. And how far do we pull this off? 100. We can do negative 100 on the Y, and negative 100 on the X, and 100 on the Z. Yeah. And we can change this back to lit, so you can kind of see what we're looking at. Let's get rid of this white sphere in the examination item, just so it's easier to see our key. So we can click on it and choose Edit BP Examination. And this default scene right here, we can just add a component, a scene, and we can just replace the default scene root with this scene. And that gets rid of that white sphere in the middle. And that's a little easier to see our key. So we get our light. We can try setting it to something like 15. We can hold down Alt and drag it off to create a new one. Negative 100, 100, and 100. I dragged it perfectly. We only want this to be 50%, so this will be 7.5. And let's drag off this one, and we'll make it X 100, Y negative 100, Z 100. And this one will be 20%, which is 3. Okay, kind of take a look at that now, and I think the lighting looks fine. So let's create a new material so we can view our render target here. you can actually see in the preview of the render target kind of what it looks like. The key's a little farther away, so let's... oh, this somehow got disconnected from our scene capture. Don't know when that happened. You can just reconnect it right there. And we'll zero it out. And instead of 40, we can make this 20 for now. Save, and as you can see, the render target's been updated. We can kind of see it right there. We can rotate this just to make it a bit easier to see, but we'll remember to rotate it back. Oh, my cat's making noises over there. We'll make sure to rotate it back, because when we want it to rotate it, we want to rotate the mesh inside the actor, not the actor itself, but just for the sake of being able to see what a render target kind of looks like right there. But let's create a material. So we'll go to Content, Materials, and we can create it here. So right-click Material, and we'll type in M, Examination. You can open that up. And the type of material this is, we don't want it to be a surface, which is just what you put on regular meshes. We want it to be user interface, because it's a material for our HUD. And we don't want it to be opaque, we want it to be translucent. And this is because we are getting rid of the background and only keeping the item. So the texture we want as our final color, that is our render target that we made. So we go to Blueprints, Render Targets, it's right here. We can just select it. And if we go back into Examination and hold down the T key and then click, it creates a texture sample for us, and it will automatically assign it to whatever we have selected in our browser. Assuming it's compatible, of course. So we have now our render target as our texture. So we'll plug in RBG to final color. And now we can see what our material looks like. And we need our alpha here to go into the opacity. But this is going to invert it. As you can kind of see, we have this weird outline. We don't want that, so we need to invert it again by getting a 1- node and just putting it through that. And now the background is black again, but it is now being keyed out. You also want to make sure that this sampler type is set to linear color. Mine did it automatically, but I know occasionally it doesn't. I'm not sure when it does and when it doesn't, but just make sure the sampler type is set to linear color. So we can save and apply this, and saving it will automatically apply. And we can do the same thing we were doing with this in Content, go to Materials, and we can kind of see what we're looking at here. Now in this preview, you can see obviously this checkerboard material is the stuff that is masked out, and you can see the key, and you can also see the building in the background. Now let's make it so this can only see the key at all times. So we can click on our scene capture, and if we scroll down here, we have this thing called a primitive render mode, and we can click it and we can choose use show only list. And we have this list down here called show only actors, and we can add as many actors as we want to this list, and whatever actors we choose, those will be the only ones rendered. So let's add one, and takes a little eyedropper tool, and let's select the examination. Great, so let's save, and now this material is updated, and you can see the building in the background has disappeared, and we can only see our key. Cool, so we just now need to be able to update whatever mesh this actor is showing, depending on what item we are examining. So we need to add that to our item data struct. So let's go into Blueprints, Structs, and open sitem data. And let's pull this down. And we need to add a static mesh so it knows what static mesh to add to our examination. So let's press new variable, and we'll type in examination mesh, and this will be of type static mesh. Choose right here, static mesh object reference. We also need a examination mesh offset, which is a float. As you can see, this BP examination right here, it is 20 units on the X value away from our scene capture, but not every item is, of course, the exact same size, and some will need to be pushed farther back to fit into the frame of our camera or be brought farther forward. So we also need a float to know how far / how close it should be to our camera. So let's create our examination mesh offset, and this will be a float. And while we're in here, we can see we have our can be used and can be dropped. Let's go ahead and also set our final can be examined. So we can just have can be examined. So we can have one each for each drop-down menu option. Change it to a Boolean, and I'm just gonna use these arrows to move it up right above can be dropped, just so they're in order, the same order they are in the menu. Of course, this is not a necessity, it's just a bit of organization. We also want the default of can be examined to be true. So let's save, and we can close that, and we have to open now our master inventory item to compile it, so that we can go into the toChildren and update variables. So for the flashlight, yes, we want it to be examined. The examination mesh, we have to get just our battery mesh. So we just choose our battery static mesh. You just want to choose the same one that the pickup actor uses. And then examination mesh offset, let's leave it to 0 for now. We won't really be able to tell until we go into game and then come back and adjust accordingly. So let's open our door key. Let's do the same thing. Oh, this is the pickup actor. My bad. Back into inventory, choose the inventory item door key. And can be examined as true. Examination mesh will be our door key, static mesh, and our offset will also leave at 0 until we can figure out how to adjust it accordingly. Alright, so we need a widget to display our examination item. So let's go into content and UMG, and this can be part of our inventory. Let's save all 3 of these. So just hit save all, and let's create our widget, user interface widget blueprint. So we call W examination, and we can open it up, and we'll go ahead and leave this to filling the entire screen. So we don't have to delete the canvas panel or set it to desired. We'll leave it to fill screen, and we'll leave the canvas panel. Let's first add a background blur, just for aesthetic purposes. So we can add it to our canvas panel, make it fill the entire thing by setting it to fill. Change all the offsets to 0. Now let's make the blur strength like 3, so it's just nice and blurry in the background. We'll give it a Z order of -1, so we make sure it's always defaulted behind everything else. We also need an image, and this image will be displaying our examination mesh. It'll be displaying the material that this scene capture shows. So let's add an image, just add it just to our canvas panel. Let's anchor it to the center, and let's make the size 512 by 512, because that's what I made it in our render target right here. If you remember, 512 by 512. And I want to center it, so I'll set this to 0 and 0. And once again, we need to set the alignment to the center, so we'll change that to 0.5 and 0.5. Let's make the image the material. You can set materials to images. So if we go to our content, materials, and this M examination material, we can set that to our image. So M examination, choose that, and there we go. We have our key displayed in a widget. Now if you want, we can also add like the name and the description, so we can go ahead and add those. We'll use size boxes, so let's just put the name on the left and the description on the right. So let's anchor this to the left middle, position Y at 0. Let's kind of drag it out a bit. We want the Y in the center, so we can change the Y alignment to 0.5, so Y0 is at the center. Make the size X 500, size Y 150, and let's bring it like 50 away from the left. Maybe a bit more, like, well, how much? Yeah, kind of want to make it even between this and this, so let's just eyeball it at like maybe 100. Alright, 100 seems fine. So let's add a text to the size box. And we want to center the text for this one. We'll write item name. We'll set it to Calibri, which is our font. Makes this one bold. Get rid of the shadow offset. And let's increase the size to like 50. Okay. Alright, let's do the same for the description. So we can actually just copy and paste this size box. Select the canvas panel and hit paste. This size box, we can anchor it to the right over here. Set the position X to, oops, not the X, well, yeah, X0 is fine. Y0 is fine. The alignment for Y, nope, not Y. Y we want to keep at 0.5. X can be 1. And what did we make this one? It was 100, so we can make this one negative 100 on the X. Let's increase the Y size a bit because it is a description. So maybe double it at 300, and then we can bring the Y down by like 75, just to keep it going down. This text will be item description. We want it to be smaller, like 25. Can be light italic, or whatever you want, and I'm going to vertically align like this. Or I'll keep it on the center of the middle. I don't know, I'm just completely eyeballing here with whatever I think looks good. And we can, for the item description, we want to make sure it auto wraps. Because if we have something really long, it can, my fingers were completely offset. It auto wraps. Let's actually, to make it auto wrap correctly, let's horizontally align fill and change the justification to center. That's what I meant to do. Alright, let's change these two texts to variables. So is variable, and we'll call this item name text. And we'll call this one is variable item description text. And lastly, before we continue, we want to be able to rotate this image, not the image, we want to rotate the actual mesh in the image when we drag our mouse around, so we can examine all sides of it. But we don't want to accidentally be clicking on any of these text or images and having it focus on all that. So we just want to overlay the entire thing with a big image that we can only click on that one. So let's add an image, add it to the canvas panel. We're going to rename it drag detection, and we're going to anchor it to the full and just set all the offsets to 0. And just to make sure it's always in front, we can set the Z order to 1. And to get rid of this white screen, we can take our color and opacity here under appearance and just set the alpha to 0. Alright, and that's all we have to do in here for now. We'll come back to it to add some blueprints to our graph. But first we need a reference to this in our inventory blueprint component. So let's go to Content, Blueprints, Blueprint Components, and BPC Inventory. And I'm just going to start closing these functions. Okay, just go to the event graph. And in our inventory, we just need to create the examination widget, so we can do it in the initialize after we did our character reference. So create widget, W examination, and let's just make this a variable, W examination ref. And next we need a reference to the actual BP examination actor right here. And to do that, we will get all actors of class and choose BP examination. And the only reason using the get all actors of class node here is safe is because we know we'll only ever have one BP examination in our world. So we can just get a copy, and it gets the first one in our world, or the one that has the index of 0, because that is the only one that is in our world. And we can just promote that to a variable. We'll call this BP examination ref. So the W examination ref is a reference to our widget, and the BP examination ref is a reference to this BP examination actor that's in our world. Now in our examination widget, we need a variable for the BPC inventory, so we can just create one. So BPC inventory ref, and we'll set this to BPC inventory object reference, and we need it editable, and we need to expose it on spawn. And then in our BPC inventory, we can set that variable to ourself. So in the examination widget, which we have a reference to now, we just need to set this widget we created, BPC inventory ref, to let it know we're talking about this one specifically. So set BPC inventory ref, and set this to self. Alright, and now we have our references all set up. So let's go back into the examination widget. We have to make a custom event to update the widget. We'll call it update widget. And we just need to update the name and the description, depending on the item. So let's give this an input of an index. We type integer. And we're basically doing the exact same thing we've been doing all these times. With the index, we will get our BPC inventory ref and call our function get item data at index with the index plugged in there. So it gets all the data from the index that we call update widget with. And from our items, we can get the class defaults, break the item data, and now we can get our examination mesh and the offset, or we just need the mesh here actually. So we can update the mesh from our BP examination actor. So let's get the reference to the actor from our BPC inventory. So we'll get BP examination ref, and we need to set this static mesh. I have BP examination open right here. We just need to set this static mesh to our new mesh, which comes from this struct. So we will get static mesh. And to make this actually clearer, let's rename it to something like item mesh. Anything that isn't static mesh, just so we can type get item mesh and then set static mesh. This can just be confusing because we'd be getting static mesh and then setting static mesh. So sometimes it's easy to get confused of when you're supposed to get, when you're supposed to set. So we are just setting the static mesh right here. We're setting this parameter inside our item mesh. And the new mesh will be our examination mesh. Now we have to set the offset for the mesh here. So we will set relative location, and let's split the struct bin because we only want to take it from the X. And let's also get the relative location, split this as well, so the Y can go in the Y and Z can go into the Z, so those will not be altered. But for the X, we can plug in the examination mesh offset. That added to the relative location of the X, because it's 20 by default. So we want it to be 20 plus whatever number this is. And lastly, we just need to change the name and the description. So we can just get our item name text, set text, I did that a little fast. Let me just show you exactly what we're taking here. Set text. Text. And the in text here will come from our item name. And we'll do the same for item description text. Set text. Text. And we have to open this up, grab description, and plug that in. Let's get a reroute node. And we can collapse that again. Compile and save. So now whenever this update widget custom event is called, it'll update everything inside the widget that we need, plus the actual examination actor. And we'll call it right before we open up the widget. So let's go to the BBC inventory. And we just need a custom event in our BBC inventory to call this custom event, because it'll be a lot easier to call it from our inventory than from the widget directly. So we're just basically making a custom event that calls the other custom event. So let's call this create examination widget. And this one will also have an input index, type integer. And we're just getting our W examination ref, a reference to our widget. And we're just going to call the update widget custom event and plug index into index. And then after we create our examination widget, or after we update it, we actually want to add it to the viewport. But before we add it to the viewport, we want to remove the inventory widget. So let's get our W inventory menu ref, and we can set the visibility, and we want to set it to collapsed. And then we want to add our examination ref to our viewport. So we'll grab our examination ref, and we'll choose add to viewport. And let's open this dropdown, and let's change the Z order to 2, just to make sure it's always on top. And now let's actually call this custom event from our drop-down menu. So we have to go to content, UMG, inventory, and inventory drop-down. And we just need to call it when we press our examine button. So we can get our examine button right here. And then on released, like the others. And let's just copy and paste these three. So we get our player ref, our BBC inventory. We can call create examination widget, and our slot index as our index. And we can now test it out. So let's hit play. And let's pick up our 2 items. Let's pick up these first, because there's like 80,000 door keys in this part right here. And let's just look at a clean slate to make it easy. Oops, I don't think I pressed E on the batteries. Okay, got it. And E. Okay, clean slate. Open our inventory. Click here and click examine. And we forgot to rotate this back. So let's change this rotation back to 0, 0, and 0. And let's hit play. 3rd time's the charm. Let's hit tab, examine, and it works. It says flashlight battery here to the left. We see an image of our flashlight battery, and we have the description here, add it to your flashlight to replenish your battery life. We still cannot drag it around, and we have a blurred background. Should also work for our keys. We have no way to close it at the moment, so I had to just close the game and reopen it. Examine. This door key, we're looking at our key right here, which is not rotated the way we want to, and use this to open a locked door. So let's create a way to actually close the widget once we opened it. So let's go to Edit, Project Settings. Let's add an input, and we're going to add this kind of universal input, and we'll call it return. And we're going to send it to escape, but we cannot use the escape key while we're previewing our game, because the escape key closes our game preview. So we're going to add another one, and this will be our backspace. And this is just because we cannot use our escape key while previewing the game. So let's close that, and let's go to our game PP and player controller. And in the event graph, we just want to call an event dispatcher whenever we hit the return key. So we'll type in input return, and let's add the event dispatcher, and we'll call it pressed return. So essentially, what we can do with an event dispatcher is in our player controller, or in anything, we're just adding it in our player controller, we can call this dispatcher whenever we want. In our instance, it'll be after we press a button, and then in any other blueprint, we can call a reference to this player controller and tell it to call a custom event when this dispatcher has been pressed. So in simpler terms of what we're doing right here, we are calling our return button in our player controller, and then in individual blueprints, we can assign what this return button does localized to each blueprint. So let's drag out press return and release. We get some options here. We want to call it. We're only going to be using call and assign for now. So we're going to call it. So after we press it, so every time we press return, this dispatcher will be called. It has to be received from another blueprint for it to do anything. So let's receive it in our examination widget. So let's go to the construct. I'm going to delete these two. And in the construct, let's cast to our player controller. It's HD player controller. The object is get player controller. And as the controller, we want to search for assign pressed return. So we can assign the event dispatcher to this blueprint, and it's going to create two nodes for us. So the first one is the one that binds the event to press return, and the second is the custom event that it'll call. So the custom event, we can call it close examination widget. Let's just bring that up there, and let's bring this over here. So every time we press return in the player controller, if our examination widget is valid, this custom event will be called. And I can test that out for you with a print string. And we'll just say close examination widget. I spelled that wrong, but I'm not going to worry about fixing it. And I can hit play. And I'm going to hit the backspace key, and nothing's happening. So let's open our, or I have to pick up an item first. Let's pick up our batteries. Let's open our inventory. Let's examine. And now our W examination is valid. And I'm going to hit the backspace key now. And it's telling us to close the examination widget. So that's just an overview of how that works. So let's delete the print string. And after we call our return, we just want to reopen the inventory. So to do that, we just need to close our examination widget and open our inventory by calling this toggle inventory event that we've already created. So when we close our examination widget, I want the examination widget to close and the inventory to reopen. So in our player controller, we have this variable isPaused in our custom event toggle inventory. What I want to do is just call this toggle inventory custom event again, but the issue is we need to first switch this variable back to false. And before doing that, I realized isPaused is not quite an accurate way of saying this. I think a more accurate way of what this variable should be called is inventory open. And that'll just update it for us. And in VPC inventory, after we set our visibility of our W inventory menu after collapsed and add our examination ref, we should just get our player controller and cast to HD player controller, and we can convert this to a pure cast because we don't need execution nodes, and we can just set is inventory open to false because it no longer is. Now in W examination, we can just call toggle inventory. Oh, we have to call it from here, of course. Toggle inventory, and this way it'll toggle it back on instead of off. And obviously we want this examination widget itself to close, so we can just call remove from parent. So let's test that out by hitting play, and let's grab something to examine, open our inventory, and when we examine, everything's the same, and then when we hit the backspace key, we are back in our inventory, and we can close our inventory like normal. Only issue is, if we open our inventory, hit examine, and now it is registered as our inventory being closed. If we hit tab again, it'll reopen the inventory in the background, and all of a sudden this becomes messy and looks kind of unprofessional. So let's go to our player controller here, and we need a reference to the examination widget. So let's just create the variable w examination widget ref. Alright, we don't need the widget in there, just w examination ref. And we have type w examination object reference. And we need to set this, so we do it in the BPC inventory. And here in the initialize, we just have to set it from our Casta HD player controller here. So we have our variable w examination ref. So out of our player controller, we can call the variable setting w examination ref, and we can let's put it before this right here, just to keep things a little organized. I'm gonna create a reroute node right there, and we just want to set the widget to this one we've created, so we can just get the variable and plug it in right there. So in our HD player controller, in our toggle inventory custom event, we just want to go to the end here, right before we set the input modes. We only have to move this one out, because we're only doing this if we're reopening the inventory. We just want to close the examination widget. So we can take our new examination ref variable, and we just have to ask if it's in the viewport. So we'll search is in viewport, and we'll create a branch from that. I am control dragging this over here, and if it is in the viewport, we just want to remove it. So we'll remove from parent, and if it isn't in the viewport, we just want to continue on. So let's test this out. So let's go ahead and grab an item. We can just open and close our inventory like normal, and if we examine and hit tab, it closes our examination again, and it just repulls up our inventory. Hitting tab again will close it, and examining and hitting backspace will just open our inventory the same. Alright, in our next episode, we'll clean up the drop-down menu and add the ability to rotate our mesh while examining it. Something overdue we should add is toggling visibility of the examine and drop-down buttons in our drop-down menu. So let's open our drop-down menu widget, content, UMG, inventory, and inventory drop-down. Right now, the use section right here, we can toggle its visibility for can be used, but we do not do the same for the can be examined and can be dropped. So we could just copy and paste this twice, plug them in. By the way, I'm in the update menu custom event, and can be examined, or let's see, switch this out for the, that's the examine button. Examine section, switch that out. You can just drag it over this part right here, and it'll update it to examine section, and this part, the drop section. And can be examined will go into this index, and can be dropped will go into this index. And that way, if we take our door key, and let's say this one can't be dropped either, and then the flashlight, let's say it can't be examined, you can see it updates. We have use and drop, and for this one we just have examine. Now hypothetically, if we have an item that can't be used, examined, or dropped, we don't want the menu to show up when we click on that item at all. Let's make it so the drop-down menu won't even show up if the item cannot be used, examined, or dropped. So let's take the door key, so BP inventory item door key, and let's uncheck examined, just for testing purposes. And when we play, did I press E? I'm not sure. And we click, it still opens the menu even though we don't see anything. As you can see, I'm hovering over the items and it doesn't register. And if I click somewhere, it closes it again and we can hover over them again. So let's open our W inventory slot widget right here. And on the slot button, we'll have to find the on released slot button right here. Open drop down menu. And we can bring these over just a bit. And let's get our player ref variable. And then BPC inventory. And then get item data at index, this function that we use quite often, and our index will be the index. Our item, get class defaults, and we can break that. And let's just let's move these out of the way a bit. And let's just get a not boolean from all three of these. Copy and paste that. And then an and boolean for all three of these. So I'll have to press add pin right here for 3 conditions. Plug it in. So if we create an if statement right here, which we will, it only goes down the true path if all 3 of these are false. Now, I want to switch that. I only want it to go through the false path when all 3 are false. So we add another not boolean right here, and that inverts it. So on true, we open the drop-down menu. On false, this means can be used, can be examined, and can be dropped are all false. If that's false, we don't want to open the drop-down menu. And now we can test it in game with our keys. And if I click on it, nothing happens. Great. Let's go back into our world with our actual camera here. There we go. I'm going to change this to something like 4, just so it doesn't, we can actually see that we can pick it up when we have enough. It's just kind of getting annoying that it takes up everything. And let's go into the 2 inventory items, flashlight, battery, and door key. Flashlight, battery, I'm going to turn this can be examined back on, and I'm going to turn the door key back to can be examined and can be dropped. So let's also make it so the drop-down menu closes when we open our examination widget and then close the inventory. For an example of what I'm talking about, if we pick up an item, examine it, and then close it again by backspace or tab, this menu is still open, and I'd rather have it open like this. So we can do that in our BPC inventory. And let's find that custom event, create examination widget. So this is called when we open our examination widget, and when we open it is when we want to close the drop-down menu. So we're going to do it right before we add the examination ref to the viewport, and we can just get this from our menu ref. Drop down. We will get the W inventory drop down, and we just have to ask if it's valid. Is valid. Use the macro. And if it is valid, we will call close drop-down menu, which is a custom event we made in our inventory menu ref. And if it is not valid, we will just go straight to adding to viewport. So now when we test it out, examine, we're examining, and we decide we're done, we hit backspace, it is now gone. Works the same if you just hit tab to go back as well. Alright, now that that's been cleaned up, let's add 2 things to our examination widget. A default rotation for each item, and being able to rotate our items in-game. So do you notice how the door key is rotated in an unflattering way when we open it? You can see we have our battery and our door key. Do a battery first. It's pretty a nice default rotation, and our door key, much more unflattering. So we want to have a default rotation for each one. So we'll do this, as always, in our struct. So go to blueprints, structs, and item data. And we'll add a new variable, and we'll call it examination mesh rotation. And it'll be of type rotator. And I'm just going to start closing all of these. We'll have to reopen a few of them, but I like to keep it all clean every once in a while. So let's open our blueprints, actors, inventory, and our master inventory item to compile it so that we can adjust our children. So now we have our examination mesh rotation. Now the battery, I'm going to leave because I think it is fine. But for the door key, we'll need to adjust. But first let's code it in. So let's go to our content, UMG, inventory. Let's just save all real quick. And let's open W examination. And we'll do this in our update widget custom event after we set the location. And we can just set relative rotation. The target is going to be the item mesh. And the new rotation will just come from our examination mesh rotation. So now we can adjust the door key. Let's try 90 on the Y, see how that looks. So let's hit play. And it is upside down, so let's try negative 90. Let's hit play again. Examine, and that looks great. And our battery should also look good because it is still 0. So it looks great. So let's add in in-game rotation. So we have to go back in W examination. And if you remember, we created this image called drag detection. This is on the top, and this is what we'll be using to detect our drag. So let's go to our graph. And here in functions, we need to select this little override tab. And we need to override the function for on mouse button down. So we'll click it, it'll create this for us. So when it detects our mouse button down, this will be called. So we need a Boolean to know if we want to be rotating our mesh when our mouse moves. So it'll just be a Boolean, we'll call it rotate mesh. It'll default to false. This will give us a warning, don't worry, we'll come back to that. And when the mouse button is down, we want to set the rotate mesh to true. So when we click down, we want the mesh to rotate. The return value needs a return value of whether the event was handled or unhandled. And we want to set this to handled. And we'll compile and save. Before we close this though, we also want to get the mouse location when we click down. So we will get the player controller and then get mouse position scaled by DPI. And out of the location X and Y, we will make a vector 2D. Just plug in the X and the Y. And we want to store this as variable. So we'll drag off, promote to variable, not local. And we will call this mouse location. Plug it in like that. Alright, compile and save. That's all we need for that one. Let's create another override on mouse button up. So when we release our mouse button, we will no longer want to rotate. So we'll set rotate mesh to false. And that'll be it. And we can return this as handled. And then we also want to override on mouse move. So when we move our mouse. And we only want to rotate our mesh if this rotate mesh boolean is true. So we'll create a branch from it and we'll plug that in. And if it's true, we'll have to get the BPC inventory ref variable we made and then get the BP examination item reference from there. So remember, this is a reference to the actual BP examination actor out here. Just get back in here real quick. And out of here, we need to get the item mesh, which is the mesh in the actor. And we just need to add world rotation when the mouse is moving. Out of this rotation, let's make a rotator right here at the bottom. So it splits it. And then we can just get our mouse location. And we also need to get the current mouse location. So this is the starting location. To get the current, we just get the same code that we used in our on mouse button down. Get player controller, get mouse position scaled, and make vector 2D. So I'm gonna copy this and I'm gonna paste it right here. And then we can just subtract vector 2D minus vector 2D. Subtract these two. And we can just break this result. And X, moving our mouse on the X axis, we want to rotate the item on the Z axis. But it will be inverted if we do it like this. So I'll let you know now we can multiply a float by a float and multiply it by -1 to invert it. And Y will go into Y. Moving our mouse on the Y axis will rotate the mesh on the Y axis. After we add this world rotation, we need to reset the starting mouse location. So we can just multiply or copy and paste this code once again and set our mouse location variable. And then we want to set the return value to unhandled because it's always updating. And now let's test that out and see if it works. So let's say E, we'll do both of these, and let's hit examine. And right now nothing happens when I move my mouse. And when I click, I'm holding down the mouse button, the can rotate, or whatever we called it, boolean is now set to true. And if I move my mouse now, it rotates. X rotates it on the Z axis, but it's inverted. And then Y rotates it on the Y axis. It seems we actually want Y to rotate on the X instead of the Y. I must have written that down wrong. Let's test it out now. Yeah, and that's much better. Except we also want that one inverted, so we can multiply this by -1 and plug it into X. And now it rotates the way we want it to. Yeah, much better. So now we can examine our entire item. If you want to change the sensitivity of how this rotates, we just have to go into our examination and just pull all this back. And you just need to add another multiply node. So another float by float. And you just need to multiply it by a number. So if you want it to be half as sensitive as it was, you can just multiply that by 0.5. And I'd do the same for the top one. If you want it to be more sensitive, you can multiply it by like 2. But I think I want it less, so I'll try 0.5 and let it play. Let's test it on the batteries this time. Let's hit examine. And that looks great. Alright, we can now rotate our mesh when we examine it. Last thing I want to go over is something we didn't in the last episode, which was the examination mesh offset. How far you want it from the actual camera. And before we start that, we can focus in on our camera here by hitting the F key. If you want to change the perspective, 90 might be a bit too high, you can do it right here with field of view. 45 might be something a little better. I could try that. But now our items might appear too close, even though the dimensions might look a little better. So yeah, as you can see, it is cut off, and we don't want that. And it gets a little too close to the camera right here. So we need to move it farther back. So what we could do is we could move the actual default item farther back, just just going to reset these two back to 0. Sometimes it gets incredibly tiny values. That doesn't matter. To like 30. So this is just the default value. But then the flashlight, or the door key, let's give it an examination mesh offset of -10, so it moves. So it's actually going to be 40 units away from the camera. We can hit play, hit E, and examine. And I just realized I put -10 when I meant to put 10. We want it 40, that just moves it back to 20, which made it look the same. And let's hit examine, and now it is farther away. And then if we go back to our battery, this one is still at 30, so it is a little closer than the door key is. For an extreme example, just to show it works, we can set this to like 100, and hit play, and examine, and you can see it's pretty far away now. But I think 10 worked, and might want to even move the flashlight battery a little closer, so we can try something like -5. And let's see how that looks. And just make sure it doesn't get cut off on the edges. I think that looks great. And that's how we deal with the examination mesh offset. Alright, that'll be it for this episode. In the next one, we'll worry about adding extra inventory slots in-game. In this episode, we'll be covering how to add more inventory slots in-game, as if your character were to pick up a backpack or something of those sorts. So to do this, we need to create a new actor called BP Inventory Backpack. We'll go into Blueprints, Actors, Inventory, and this will be very similar to a pickup actor, but it will not be a pickup actor, so we're not making it a child of this. I'm gonna just click on something and focus on it with F to get us back in our scene here. So let's create a new blueprint class of type actor, and we'll call it BP Inventory Backpack. And we're gonna open that up, and it needs a variable, and this will be amount of slots. And this will be the amount of slots it's adding to our inventory. We'll make it of type integer, and I'm just going to default it to 2. Let's also make it editable so we can change it per actor. And like I said before, the way we pick up our backpack will work the exact same way we pick up our inventory items, so we can copy and paste some of that code. But first let's add a static mesh, and this will be our backpack mesh. And if you have a actual asset for a backpack, this is where you want to add it. For us, we're just going to make it a cube. We're just going to search cube. Choose this one. It's pretty big, so let's just make it 0.3 in size. And we can kind of just drag this out to the world and see if that's a good size. Alright, that looks good to me. Yeah, that's our backpack. And let's also create a overlap sphere for this. So just search for sphere, add sphere collision. And let's make the size 500. So it's really big like the others. And let's move our character outside of this overlap sphere, because spawning inside a sphere can sometimes cause issues if you have the functions for begin and end overlap, which we will. And speaking of those, let's actually create those now. So let's create a begin overlap, and click on the sphere again, and make an end overlap. And we'll also need the event tick, and put that there. So let's open our pickup actor so we can copy and paste some of this code to save some time. So go to pickup actors and pickup actor master. And we have our tick here. This is our input action and our begin and end overlaps. So let's first do the begin overlap. So let's just take all this, let's copy it, and in the inventory backpack, let's go to our begin overlap. Let's paste. Let's drag this here. So first we have our casting to our L1 character, and we want to plug this into other actor, and then we set this character ref. It's grayed out because we don't have a variable for player ref. So if we right click on this and press create variable player ref, it'll just create it for us. That'll be blue, and we're all good to go. For prompt widget, this is also grayed out because it's talking about the arrow widget above our mesh, and we have not added it to our backpack yet. So let's do that. So let's add a widget, and we'll just call this, I would call it prompt widget, but I want to show how to do it if it's named something else other than the pickup actor. So we'll just call it pickup widget instead. Here, F. And let's change the widget class here on the side to pickup prompt. It's huge again. We want to leave the draw size at 500 by 500. And let me check the pickup actor to see the size we made it here. It's 0.03. So it's 0.03. And we'll bring it up. Maybe 30 on the z-axis looks good. We're getting a blueprint bad because we have a lot of errors, and we'll go back to them. So this prompt widget right here, it's not the prompt widget anymore, it's our pickup widget. So we can just drag it out and replace it by just letting it go on top of the prompt widget. And then that sets the visibility to true. That reminds me, I also want to set the visibility default to false. Okay. And then it sets the update actor variable to true, which we also don't have. So right click and create variable update actor. Same we did for the play ref. Now if we compile, we have all our variables. This no longer says blueprint bad, and we're good to go. So now let's go back into our pickup actor master, and let's copy and paste the on component end overlap. And plug that into other actor. The only thing we have to change is this prompt widget because it is now pickup widget. And sets our update actor variable to false, and this doesn't require variables. And then lastly, on our event tick, we want to copy and paste all this too. So I'm just going to kind of go through it one by one. This is setting the world location to the widget distance above mesh, which we can add as a variable for ours as well. Then if it's updating the actor, we line trace to our player. We set the visibility to true unless it is obstructed by something. If it sets the rotation so it's always facing us. Oops. And it changes to the E prompt if we're close enough, and then if we're close enough we enable input. So I've just selected all of that. Copy. In the inventory backpack, let's paste. Let's bring it all over here. You have to kind of just skim through it again. Prompt widget instead is pickup widget. Our static mesh is now our backpack mesh. And our widget above mesh, we can create this as a variable as well if you want. And we can make the default here as 30, which is what we set it to there, and make it editable so you can change it. We have these errors, and those are farther in. So update actor true, player ref camera, we're good. Line trace by channel. Prompt widget is now pickup widget. Sixth branch on the top, set visibility. Change all the prompt widgets to pickup widgets. Rotation, I believe that's most, if not all of our errors. And let's check down here. And pickup distance, which we also want to make a variable. So create variable pickup distance, make it editable. Let's compile. We've fixed them all. Let's change the pickup distance to the same as it is in our pickup actor, which is 150. But I think we made both of the ones 200 in game, so we'll just change this to 200 because that seemed to work a little better. All right, so we can make sure that the widget now works. So we have our backpack over there. We come in, and our widget now exists, and it rotates to follow us. And if we're closer than 200, it turns into an E. And pressing E won't do anything, but it does enable our input. So let's go to our BPC inventory. So blueprints, components, BPC inventory. And let's make a function, add more slots. and it needs an input of amount. This is just how many slots are we adding to our inventory. Make it of type integer, and we'll come back to this real quick, but let's go to our inventory backpack actor, and let's add an input action, which is our E key. If you remember, it's the same as our pickup actor master, and it will only register as clicking it if our input is enabled, which only is once we're close enough to pick up the backpack. So once we press it, we want to get our player ref and get the BPC inventory. And from the BPC inventory, we want to call add more slots, with the amount being our amount of slots variable. After we add more slots, we just want to destroy our actor to imitate actually picking up and equipping the backpack. So now we can go back into BPC inventory, and here we can get our player controller, and we'll have to cast to our HD player controller. Right click and convert to pure cast. We could definitely make our player controller here a variable in the initialize, because I think we use it more than once. Yeah, we use it here too, but it is up to you. So with our player controller, we just have to get our inventory slots, because our player controller, if you remember, is where we keep the amount of inventory slots we keep. And we just need to also set inventory slots. And the new number is the old number plus the amount, or the amount to add. This way our game will know we have more slots in our inventory actor component, but we also need to add it to our slots grid in our widgets. So let's go to our inventory grid widget, so UMG inventory, W inventory grid. Let's go to graph. And all we have here is just this generating these slots. So let's add a function, and we will call it add more slots in here as well, with also the amount, the input amount, sorry about that, as an integer. And we just have to get our inventory grid panel right here and get the children count. So how many children does it have? And in this case, children are our inventory slots. And we just have to make a local variable from this. We'll call it local amount of slots. So we need to create a for loop after this to add each slot. Sorry, not a for each loop, just a regular for loop. And the first index is 0, the last index is amount minus, get integer minus integer, minus 1. Since this starts at 0, to get the proper amount, we need to get 1 less than our amount. And we need to just copy and paste all this code right here from the pre-construct. So we have our for loop, and we just create new slot widgets, add it to the slots array, and add the children. So it's copy and paste right there. But we can't plug in this index to index like we did on the last one. And this is because the index here restarts at 0 when we need our 2 slots in this example to start at as the index is 8 and 9, because if we are adding 2 from our backpack, we have 2 slots as default. We need to add it to the indexes 8 and 9, which are the 9th and 10th slot. So to do that, we need to get the local variable, local amount of slots, and we add it to the index, and we can plug this amount into the index here, and also right here for figure out where the children will go, which is also the 2 spots that in the pre-construct this regular index goes to. Now in BPC inventory, after we set our new amount of inventory slots, we just need to call that function. So with W inventory menu ref, we can get our W inventory grid, and we can call add more slots. And the slots we're adding comes from the input here, not this, because that's the total amount of slots. Lastly, we just need to initialize all the new slots, and we can get the slots array right here at the inventory slots, because this is an array of all our as inventory items. Lastly, we just need to initialize all the new slots. We can just get the slots array from our inventory menu ref. We get the slots. Oh, I mean from our inventory grid slots array. And we're just going to reinitialize all of the slots, not just the new ones. Just to keep it simple, we're going to reinitialize all of them. It won't hurt any of the ones that are already there, even if they have items in it. So we're just going to get a for each loop, and off the array element we will call initialize. The inventory menu is our W inventory menu ref. Okay, so let's compile and save, and let's give this a test. So first, we'll just open our inventory, and we have our 8. Let's go over here, pick up the backpack, it disappears, press tab again, and we have 2 new slots. And we can still get items as normal, and it doesn't reach the rest. We can also grab an item. Now we have 4 items in our inventory. Grab our backpack, and we still have our 4 items. We can also take our door keys over here. We can set the amount up to something above the amount of our previous inventory slots, like 9. Because currently we only have 8. And we can pick up our backpack, and now we have 10. If we pick up our keys, oh, something isn't working. Give me 1 second. Oh, and I've figured out our issue. I missed one small step. Go into your BPC inventory, and here in our add more slots function, right after we resize our inventory slots from our player controller, we never told the BPC inventory itself that this inventory slots array was resized. So it doesn't know how to add anything to the new slots. So we just drag this off here, right after we set our slots in our player controller. We just take our inventory slots array right there, and we will resize. And let's plug this in here. And the new size is our new inventory slots amount from our player controller. So we can just take it right there, and now it should work just fine. So let's pick up our backpack. We have 10 slots. There are 9 keys over there. We pick them up. They've disappeared because we've picked up all 9. Alright. So everything seems to work great. We can even increase this amount of slots to any number we want. So let's say I want to add another 8. Just press play. Pick this up. We now have 8 more slots. And everything works accordingly. Alright. Great, so that is how you add more inventory slots in-game. All that work into creating an inventory if we don't use the items, right? Let's give a purpose to our flashlight batteries first. Right now, our flashlight is literally just us toggling our light on and off. So let's make it an actor component instead. Alright, so let's go into blueprints, blueprint components, and we've created a component for our inventory and our movement. And now we're going to make another one for our flashlight, so it can easily be added to our first-person character. So let's right-click, and let's go to Blueprint Class. We just want to choose Actor Component right here, and we'll call it BPC Flashlight. So let's open that up, and since we'll need it pretty soon, I'm going to open up my first-person character as well. So I'm going to go into Game BP, Level 1, L1 Character. So let's go back into our Blueprint Component, and we're going to need a variable of type light so that we know which light we're influencing in our character, which is our spotlight right here. We can actually rename this to flashlight if we'd like, to make it a bit clearer on ourselves. This is the light we want to be influencing. So let's go back into BPC flashlight, and we're going to create a new variable, and we're going to call it, we'll just call it light, and it'll be of type light. You can scroll down, and it's right here, light object reference. And I explained this in a previous episode, but the light variable can include all the different types of lights, such as point lights, spotlights, direction lights, etc. Since we know this is going to be a spotlight, we can change this to a spotlight, make it an object reference. If you'd like, there's no reason you would change it, as a point light or direction light would not really work for a flashlight, so we can go ahead and keep it as a spotlight if you want. I just wanted to explain both very quickly. So let's create a function. This will just be called toggle flashlight. And we can just copy and paste the toggle flashlight code from our L1 character. So if we go into our event graph, just pull that over here, and let's go ahead and find it. So it's wherever we hit our input flashlight toggle, which is set to F. So we can just take all this code right here, copy it, and go back into our BPC flashlight toggle flashlight function and paste it. Control V. Okay. Don't know why that didn't work for a second. I probably just didn't hit Control C. Alright, so we have the same code here. We have our flashlight variable, and this is not the variable we have here. This is grayed out because our BPC flashlight doesn't know what we're referring to with this variable here, because it's a variable from our L1 character. But it asks if it's visible, and if it's true, we set the visibility to true, and if it's false, we set it to false. Now I can't remember if I mentioned this way back when we did the flashlight, but the reason we're using a branch and not just plugging this in here with a not boolean, which would just be faster, get rid of a couple nodes, is because in the future we will need two separate paths, which is why I made it like this. But we just need to replace our flashlight variable here with our new light variable here. And we can actually, I changed my mind, I want to rename this to flashlight light, so it's a bit more clear what we're working with. And we're getting an error when I compiled because it doesn't know what variable this is. And if you hold down Control and drag these and try to put it in our flashlight light, it does not actually work. Well, it will create a conversion node for the root component, but that doesn't work for this either. And the reason this variable isn't compatible is because if we click here, we search spotlight, it actually needs to be a spotlight component. The spotlight component, or any light component, references the actual light itself. So we need to change this to a spotlight component object reference, change variable type. We won't get any errors because this isn't plugged into anything. And now, if we take all these and plug it in, it works just fine. Because this flashlight variable here, in our L1 character, pulling off here, as you can see, it says flashlight spotlight component and not spotlight. So we can compile and save again. We can delete this right here. Alright, so we're going to have to expand on this a bit, but before we do, let's go ahead and add it to our L1 character. So if we just go to add component and search BPC, we now have BPC flashlight as well. Click on it, we don't need to rename it. And you can see on the right here, under default, we have this option for our flashlight light, and we need to set it to this flashlight right here. So we can do that in our initialize. So we can open the initialize function, just right here. And we'll do it right after we initialize BPC movement before the widgets, just to keep things organized. So we need to make a new initialize function for our BPC flashlight. We'll call off initialize right there. So go back into BPC flashlight, create a function. We'll call it initialize. And we can give it an input of L1 character object reference, and we'll call this player. And off here, we'll first promote it to a variable just to have in case we need it in the future, and we'll call it player ref. And after we set that, we want to take our flashlight component, which automatically goes into our components category. So if you don't see it, just open up components here, it's right here. And we just need to set it. And we are setting it to our character's flashlight right here. So we just call off flashlight, and we could scroll down, it'll be at the bottom, and we can just get flashlight right here. And we will plug it in like that. So compile and save. Now back in L1 character, we can just call our initialize function, and our player will be self. So it'll just be the L1 character we are in right now. So now our BPC flashlight in this L1 character knows that our flashlight is this flashlight right here, and we just need a way to call the toggle flashlight function. So we'll do that by replacing our code here under our input with the new function. So we can just delete all this code after input action flashlight toggle, which is our F key, and we'll just get our flashlight right here, and we will call toggle flashlight unpressed, or you could do unreleased, whichever is more suitable to you, and we'll compile and save. And now when we hit play, everything should be pretty much the exact same, or how it appears to look in our game. So we hit F, I'm going to release the F, it goes away, release F again, it comes back. So just hitting our F key does the exact same thing it did before we started this episode, but now it runs through our component rather than our character itself. So now we can add some battery and battery levels. So we'll need 3 floats for this, as always, and it'll be max battery level, and let's make it a float. We need a current battery level and a min battery level. And this should all look familiar as we've used the exact same technique for our stamina. We can make our max battery level, let's compile so we can adjust the values. But let's make our max battery level 100. Our min can stay at 0. And let's make our current just 50 so it starts off halfway. And we'll need functions for depleting and adding to battery life. So let's make those. So we'll deplete battery life and make another one, add battery life. Let's start with add battery life. We can just make an input of amount. So let's make it a float. It'll be of type, or the name will be amount. And this is just how much battery we're adding. So we can just get our current battery level, and we need to set it first thing. And the number we're setting it to is the current battery level we already had, plus our new amount. Now we want to make sure this doesn't go above our max battery level. So we will add a clamp. So we'll search for clamp float. And we'll just put the return value in there. The min will be our min battery level. And our max will be our max battery level. And once again, this will just take this number, put it through here to make sure it does not go above our max or below our min. And if it does, it just sets it to the max or the min. And we will put that to our battery level. So we can compile and save. And we can just copy all of this to our deplete battery life. Let's copy that real quick. And let's just give deplete battery life an amount input as well, also type float. And instead of adding, we are going to subtract. So replace this with a float minus float. Put that into value. Oh, and I just realized I made a small mistake. We don't actually want the depletion of our battery life to be called with an amount in an input, since we'll be doing this incrementally over time as we use our flashlight. So let's actually remove this input. We don't need it. And for the output here, we're going to promote it to a variable, and we're going to call it depletion amount. So sorry about that, but it's all fixed now. And we're just going to set the default number of it to 1. We'll leave it at 1. So let's go back to our toggle flashlight function. And after turning on the flashlight, we want to set a timer to deplete our battery. So if it's visible, it's false, and we set the visibility to true, our flashlight's now on. we want to start depleting the battery. So we will call a set timer by function name. Another reason why we're not using an input is with the set timer, we cannot use inputs because we just type in the name here and there's no place to use the input. So set timer by function name is deplete battery life. Make sure you've spelled it exactly the same as our deplete battery life function. And we need to know our time. And this is how long to wait before executing our function. And if we set it to looping, which we want, it'll loop this, of course. So it'll wait the amount of time and then call the function again. So we want to promote this to a variable so it's easy to alter. So right click, promote to variable. We'll call it depletion speed. And we're going to set the default to 30. So every 30 seconds, this deplete battery life function will be called. And since our depletion amount is set to 1, this means every 30 seconds, 1 unit is depleted from our battery level. And the reason that might seem like it goes pretty slow is because this is the part where I warn you to make it not go too fast. Probably the most repetitive issue I see in indie horror games are flashlights that run out of battery too fast. You don't want your game to become a battery hunting simulator. A good example of this is to think of the Outlast games. And while he uses a camera and not a flashlight, it still takes quite a long time for the protagonist camera to run low on battery. This way it's easier to concentrate on the story of the game rather than stressing about your battery the entire time. You still definitely stress about batteries, but as long as you have one in your inventory, it gives you the space in your mind to worry about what's actually happening in the story. Depleting 1 unit of battery every 30 seconds will also seem fairly slow for testing it out in a level where there's no goal and there's nothing we have to concentrate on. It definitely seems shorter. But when your character's running around collecting items or running from your antagonist, etc., it will go by in the background and work a lot better like that. So that's why I chose these speeds and times. We'll also alter them just to test, because I don't want to be sitting here for a few minutes to actually make sure it's working. So when we turn off our flashlight up here, we want to stop this timer. So we'll just call clear timer by function name. And we can just copy and paste this deplete battery life. We don't have to set the objects to anything because the object is ourself. So let's reopen our deplete battery life function. And we just also want to stop the timer if we run out of battery. We don't want to keep subtracting from a battery that is completely dead. So let's call an if statement here. And we're just checking if the current battery level is less than or equal to our min battery level. If this is true, we want to turn the flashlight off and then clear the timer. So we can go into toggle flashlight, and we can just copy these two things here, Control C and Control V. And the target for set visibility is our flashlight light. And now we also want to make sure we can't turn the flashlight back on if we are out of battery. So in toggle flashlight, on the path where it turns on, before we turn it on, we just have to make sure that we have battery. So we'll create an if statement, or a branch as they call in blueprints. And we just want to make sure our current battery level is greater than min battery level. So if we have any battery at all, we can turn it on. All right, let's test it out. But before we do, I want to change the speeds a bit and create a debug so we can see how much battery we have. So in the tick, can't remember if we still have it, tick. So let's create one, event tick, in our Elrond character. And we're just going to print string, and we're gonna print our battery life. So let's take our BPC flashlight, get our current battery level, and plug it into string. So let's open this up and let's plug in duration to delta seconds, and this way it just won't flood the left side of our screen and we'll just have one, because the duration only lasts 1 frame. So compile and save. And if you want, you could change the color of the text so it can differentiate from our stamina. So let's also click on our BPC flashlight here, and under default we have all these settings. Let's just change the speed to something very, very low, like 0.1, so this way it'll only take 10 seconds for our battery to completely deplete. Oh, I guess it would take 5 seconds because our current battery level is 50. So let's change our current battery level to 100 so we start with full battery. We also want to take our flashlight and let's set the default visibility to off so that it doesn't start on and it doesn't take away some of our battery there. So we'll search visible and we will uncheck this and we'll compile and save. This will work because remember, when we're toggling, we toggle based off whether it's visible or not, so we don't have to update any booleans. So let's go into our level and press play. Our flashlight is off because it started. Up in the upper left we have a number right there. It says 100. It's yellow, so we know it's talking about our battery. And if we turn it on, it starts depleting, and once it reaches 0, the flashlight should turn back off. So let's see if it does that now. And it turns off. Let me try to turn it back on, and I cannot, and that's because we have no battery. If we turn it on and then turn it off again, our battery stops depleting and we are able to turn it back on because we still have battery. So that works perfectly. So now let's add the ability to actually put new batteries in our flashlight. So we'll do this through our inventory items. So let's go into blueprints, actors, inventory, and we're going to need a player reference in our flashlight battery. If we open the inventory item up, we have this use item here, and right now it just prints a string when we use it, but we need to reference our character so we can reference our blueprint component flashlight, etc., etc. But since many of these inventory items will likely need to reference the character, we're going to do that in our inventory item master so that we can just grab it from our master instead of trying to reference it in every single inventory item. So if you open our inventory item master and we go into our begin play, we can just cast to L1 character. Object is get player character, and we will promote this to a variable, and we'll just call it player ref as always. And now if we compile and save, we can access that from our flashlight. If we just right click and, oh well, we see it right here. If you don't see it here, you might have show inherited variables turned off. This needs to be turned on to see all the variables you can access from the parent class. But either way, even if this is off, you can still reference it by searching for player ref. You just don't see it in the sidebar. But I'm going to keep this on. So we can get our player ref, and we can get our BPC flashlight. So we can get the flashlight component from our player ref, and we want to call our add battery life function. I'm just going to delete our print string right here, so we don't need it anymore. And we just have to add an amount. I'm going to make this a variable, so it's easy to change. So I'm going to right click, promote to variable, and we'll call this battery amount. And if we compile, we can change this. I'm going to set this battery amount to 100, so every time we take a battery, it completely refills it, since that's how real-life battery works. Adding 100 is always safe, because remember, it is clamped, so it will never go above 100 in our actual battery life. So we can actually test that out now. This is how quick it is to set up the use item for any inventory item now, since we set it up in a very efficient way. So we can just hit play. Let's find one of our batteries right here. Let's pick them up. And I'm just gonna move over here where it's slightly darker to see our flashlight better. And our flashlight battery is 100 up there. We don't want to take it now because we don't want to add any battery life to a full battery. We don't want to switch it out. So we can hit F and let it deplete a little bit. So 66. And if we go into our inventory and use this item, our flashlight battery is now 100 if you look in the upper left. it has reset it to 100. And that's really how simple it is to add the use function to any one of our items in our inventory. So let's also test it with the flashlight going out and being able to turn it back on. So if we wait all the way till it goes to 0, then it should turn off. And we can't turn it back on, but if we put another battery in, we can now turn it back on. That works great. And lastly, we only want to be able to use our battery if we don't have a full battery. You don't have to do this step. You could leave it up to the player if they decide they want to switch out a perfectly fine battery with another one. But I think many people would be annoyed to see they've wasted a battery if they already have a full one. So we can just go into our inventory item flashlight. And before we add battery life, we can take our flashlight and we can get our current battery level, and we can just make sure it's less than our max battery level. So we'll also get our max battery level, and we only want to continue with this if the current battery is less than the max battery. I'll create a branch, control click to drag that over there, and off the true path we will add battery life. And we won't do anything if it's false. Actually, just realized that's not true. If it is false, we want to make sure we don't remove the item from our inventory, because it will still do that even if it goes off this false path. So we have to actually go into our master item to make a quick change, and the variable we want is going to be called use item success, and we do want it to be a boolean. And then in the flashlight battery, we can just set this boolean off the two paths. So if this is true, we successfully used our item, and if it's false, we didn't. This is a boolean we'll be able to use on any of our items, as many of them might have the possibility that we don't successfully use it. But let's actually make this boolean do something in our BPC inventory so it doesn't remove our item. So let's go to blueprints, actors, blueprints, components, and inventory. And we can just open our use item function. And let's go over to where we call use item. And remember, we call it in two separate ways. Essentially, after we use the item, we want to check if it was successful, and if it wasn't, we don't want to remove our item here. So we'll drag that out just a little bit more. And from our get actor of class right here, we can just take it from this reroute node. We just want to ask use item success, and we only want to continue if it's true. So we'll make a if statement, just create a branch, and we'll plug it in like that. If it was successful, we want to just continue, and we want to do the same thing for this use item down here. So if that was successful, and we'll have to plug this into our get actor of class right there. So only if we successfully use the item will it remove it from our inventory. We can test that out now by hitting play. Let's grab a flashlight, and we can see our battery life is currently at 100. And if we click here and we hit use, it was not successful, and we still have 4 batteries in our inventory. Oh, we're getting an error. Let's see what this error is right here. Oh, sorry about that. The error here is the target for the use item. We took it from this get actor of class, but we need to take it from this spawn actor, because if it comes through the not valid, this is where our reference is to our inventory item, not here. So we just need to switch it to right there, and that'll get rid of our error. And if it's false, you just do something like print a string, put the false in there as well, and we can just say use item not successful. Hit play. Let's test it one more time. Get our battery. See, our flashlight is currently at 100% battery. We try to use it, and it says use item not successful, and our stamina as well. So, and we can test it by getting rid of the battery a bit and using it now, and it works. Back to 100, try to use another, not successful. And that is how you implement using your batteries for your flashlight. So next, let's have our flashlight fade intensity as we lose battery. So what we want to do is open our BPC. So next what we want to do is have our flashlight fade intensity as we lose battery. Once again, this is a design choice for what you want in your game. Some people prefer fading flashlights, some people don't. It's up to you. But the way we're going to do it is we have to go into our BPC flashlight. So let's go into Blueprints, Blueprint Components, and BPC flashlight. And let's just dock this up here. And we need a new function. And we'll call this set intensity. And basically in this function, we just want to set our flashlight's intensity. And we'll be able to call this as our flashlight battery depletes. But before we get started, let's open our character. So it's in Game BP, level 1, L1 character. And I just want to remind everyone that with this flashlight here, we are not using the intensity. I've already brought this up in a previous episode, but we are using the IES intensity scale. This is just the intensity based off our IES texture. If you are not using this, this is unchecked. You want to be adjusting this intensity right here. So I'll go ahead and check that. And we can go back into our flashlight. And here we have set intensity. So let's go ahead and grab our flashlight. It's under the components category by default because it's a component. Puts it there automatically. So we can drag this out. And we just want to set IES intensity scale. If you are not using an IES texture, you would just set intensity, just like that. And you know, if you want to decide to kind of switch between both, or you haven't decided yet, you could always hard code that in by just ask if we're using the IES texture. So use IES intensity, we want to get, and then we could just create an if statement or a branch. And if it's true, we set the IES intensity. If it's false, we set the regular intensity. This is just if you haven't decided whether you want to use this or not, you can just toggle this off and it'll work either way. I'm just going to use the IES intensity because I know that I don't want it to change from our texture here. So I'm just going to delete these and plug this back in. So we want to get a map range for this value. So if we drag this off and search map range, we want it clamped. So if you don't remember, it takes a minimum and a maximum value, and it converts them to a separate minimum and maximum value. So the in range, we want it to be our flashlight battery, so we can get our min battery level, which is 0. And our max battery level, which is 100. And so it'll take the numbers 0 through 100, and right now it's converting them to a range of 0 to 0. And we don't want that. We want a minimum intensity and a maximum intensity. If we go to our L1 character, we have our IES intensity scale here. I left mine to 1, but you can make the maximum whatever you want right here. I want the maximum brightness of our flashlight to be 1, so I'll put it at 1. And our value here is our current battery level. So just to reiterate, it takes our current battery level, which let's say, for example's sake, is 75, and converts that number between 0 and 100 to 0 and 1. So we would get an output of 0.75, because this is essentially just dividing the entire thing by 100. So we'll compile and save that, and that's all we need to do here, I believe. So we can open our function deplete battery life, because we want this to we want to set the intensity every time our flashlight battery is depleting to update it. So before this if statement at the end here, or this branch, we want to set our intensity. Now remember, when the flashlight is on, our function deplete battery life is called, I believe it's every tick. No, it's not. It's every whatever depletion speed is. I got that mixed up with something else for a second. but it's called every 30 seconds in our case. But whatever it is, we just want to call set intensity at the exact same pace. So we don't need to call another timer. We can just set intensity inside deplete battery life. But we don't want to do it before this if statement because this chooses when to turn the battery or turn the flashlight off when we've run out of battery. So let's take our set intensity. And we just need to call it. We can just bring this over here because that's technically happening second. Just make it a bit more clear for ourselves. And we want to add it into add battery life as well, so it updates when we put a new battery in. Lastly, we need to add it to the toggle flashlight right before we set our visibility to true. So right here, right before we turn the flashlight on, we want to set the intensity. Now we can test it out. I'm going to change the depletion speed to something like 1 or like 0.2 so we can test it a bit faster. So let's hit play. And let's turn on our flashlight and watch to see if the intensity slowly goes down with our battery. So I hit F. And we're just watching the light for this. But as you can start to see, it's fading out, and right when we hit 0 battery, it should be out completely. And it is. I can't turn it back on. So that works perfectly. Now, but if you don't want it fading the whole time, and only at the end, which I would highly recommend over the prior, we'll have to go into the set intensity function here, and change value, since flashlight battery depleting the entire time can actually be quite annoying as it just immediately starts getting darker as you put a new battery in. Sometimes it's better to only have it start depleting right at the end as a visual reminder that you need to put a new battery in your flashlight. And I believe it is more realistic with real flashlights, but I'm not sure. Don't know how real flashlights are actually made. Luckily, this is actually fairly easy to change. So instead of our max battery level here, I'm just going to break that. You just want to choose the percentage of when you want the fading to start. So if I want to have it start fading at 20% battery life left, I'll just change this to 20. So now our in range is 0 to 20, and our out range is 0 to 1. And since this is clamped, everything above 20, which we will have values above 20 anytime the battery life's above 20, outrange B will stay at 1. It won't multiply above itself because this is at, say, 40. That's why it's clamped. If it was unclamped and our battery life was at 40, the outrange B would be 2. So that's just another example of the difference between map range clamped and map range unclamped. So if we go in now and we hit play, just look at this dark part of the wall again, turn our flashlight on, it's going to stay at the same intensity until, if you look in the upper left, that hits 20%, and then it'll start fading. Now. Perfect. And that's what we get there. Now, this of course will happen a lot more gradually, as I'm just going to delete this max battery level here, as our depletion speed is going to be a lot higher. 30 seconds is what I put at it. But I definitely like that better. And as of right now, I will call our flashlight done. Health is going to work in a similar way to our stamina and battery setups, with a maximum health, a minimum health, and a current health. And I've decided I want to make this a blueprint component as well. Remember, this is one of those instances where you don't have to make this a component, but I personally prefer to use them because it's incredibly easy just to plug these into other characters or AI without having to copy over a bunch of code. Health especially, I think, is a good one because you can add it to AI characters, change their max health, and you're immediately done. But let's go into blueprints and blueprint components, and let's make our fourth component. So we'll right click, blueprint class, actor component, and we will call it BPC health. Let's open it up, and we will need the 3 variables we were talking about. Will be min health. I'm gonna make this a float. Current health, and max health. We have to create a new functions. Luckily, a few functions. Sorry. Luckily, they're pretty easy. First one will just be for removing health, so we can just call it remove health, and it'll have an input of type float, and this will just be the amount we want to remove. And we just want to get our current health, and we just want to subtract the amount, and then set our current health as that amount. We don't want to set it directly. We want to clamp it because we don't want it to go below the minimum or above the maximum. That's why we take a clamp float, plug this into the value, and the minimum is our min health and max health. Speaking of this, I forgot to set the default values. So for max health, let's do 100. Min health can stay at 0, and current health, I'm just going to start it off as 75. Now we can just duplicate this function, and we'll call it add health. And all we have to do is change this subtraction to an addition, float plus float, and plug that into the value. And now we are adding health. Now let's go into our L1 character. If you don't have it open, it's in Game PP, level 1, L1 character. Excuse me. And we can just add it to our list of blueprint components here. So let's search for BPC health. And here under default, we can change the min, current, and max. Let's go into our event graph just to create some debugs. Did we create? Yes, we created our debug thing right here. So we already have something mapped to 1. So let's just search for input 2 and input 3. Put 43. It's my favorite key on the keyboard, the 43 button. Alright, so if we press 2, let's just take our BPC health. Let's remove health. And the amount can be anything we want. Let's say like 25. And I like to kind of make it an odd number to make sure the clamps work well. And then we want to just print a string. And we want to print what the health is. So get current health and print that string. If we press 3, let's add health. Just gonna bring this up here. And the amount can be also 27. And then we just want to print a string as well, so we can just do that. So let's test that out. Let's hit play. And if we start hitting the buttons 2 and 3, you'll see a new string pop in the upper left that displays our current health. So I'm gonna hit 2. It's now at 48. 2 again, 21. And 2 again, 0. 21 minus 27, but clamped to 0 is 0. We hit 3, we have 27 health. 3 again, 54. 3 again, 81. And 100. Great. So let's change this so our bandages, which is the new item, give us health as well. And it's relatively easy. So we have to open the inventory item for bandage. It won't work just opening the pickup actor, of course. But go into our blueprints and actors, inventory, and we want our inventory item bandage. Now we have this event use item. Remember, if it's not there, I'm just going to delete this. You can just search event use item because it's an event we created in the parent class, so it can be called from any of the children. And all we have to do is get our player ref right here, and we just have to get the component. So get BPC health right at the bottom there. And all we have to do is call add health. And we just have to choose the amount that we want. I'm going to make this amount a variable just to have it and to change it. So let's just call this amount of health to add. It's a bit clunky of a name, but it gets the job done. We can compile and save, and you can just choose how much health you want this to add. You could have it be the type of game where this completely replenishes your health or does a certain amount. I'm going to do a certain amount, 30. Now it's pretty self-explanatory what this does right here, but we don't want to be able to use our bandage if we already have full health, just for the sanity of the player. So before we actually add health, we'll just get our max health and our current health. And we just want to make sure our current health is not equal to our max health. So we're just checking if the current health is less than max health. Create a branch. And I'm control dragging to bring that over there. If this is true, we add health, and if it's false, we do not do anything. Except we do need to add our success booleans, use item success, because if the use item success is false, it will not get rid of the item in our inventory. So right here, use item success is true, and here it is false. So I guess I lied. There is something that happens off this false node. It's the use item success false. Compile and save. Alright, let's test this out. So let's hit play. And let's go pick up some bandages here. Gonna wait for the stamina to replenish so the strings don't get us confused. There we go. And actually we should print string of what our health is, just so we know. So in our add health, that's going to BBC health, add health. Let's just quickly print a string every time we add health. So just what the current health is right there. So we can easily keep track of, make sure the bandages are working. So let's try this again. And before we use them, I'm actually going to hit 2. Oh, well, I got overlapped with the stamina, but our health is now at 40. Or I'll hit it again. Okay, our health is now at 21. Now, if we click use on a bandage, it'll print the string of what our new health is, which should be 51. There we go. And we'll use another one, 81, and we'll use another one, and we're at 100. Now we shouldn't be able to use anymore. You see we have 12 down there. I'm going to hit use item not successful. So nothing happened. So now our bandages successfully give us more health. In the future of this health, we will add screen effects and a death function, so it spices it up a bit more and looks a bit more like what you probably want for your game. Let's add proper UI for our battery, stamina, and health. I want to make it clear you should be very cautious moving forward with your game, with your game's HUD. Since you want to make your game as immersive as possible, since that's the goal of many and probably all horror games, many times not having any HUD or having very little HUD, such as just the crosshair, is a viable option. It depends strongly on the tone of the game you are making, but if you decide you do want a progress bars for your health, for your stamina, for your flashlight, all that will be shown in this episode. So I made a few textures for us that you should replace with your own in your game. We're going to put all 3 of those progress bars I just mentioned in a small box on the lower left section of the screen. But you can obviously place yours wherever you want. This is more about how to get those bars working rather than the layout you want. So I'm just going to go into my textures folder right here. And I'm going to import our new textures. So just hit import. So just navigate to the place where you downloaded your icons right here. And we're just going to select all of them. There should be 3 icons and 2 progress bars, one for empty and one for full. We're just going to open. And I'm just going to save right now. And we can select all 5 of the new ones. And we're going to right click and we're going to asset actions, bulk edit via property matrix, so we can edit them all at once. And under texture, filter, oh, I'm sorry, no, we don't need that actually. Under compression settings, we want to set it to user interface 2D. And under level of detail, texture group, we want to set that to UI. File, And save. I'm going to close that. And they're looking great. So let's get out of the textures folder and into our UMG folder. And we need a new widget. So let's right click, user interface, widget blueprint. I'm going to call this W progress bars and open it up. So we'll delete the canvas panel because we don't need this to lay out on our screen. And we will change this to desired, or desired on screen, I mean. Once again, the difference between that is with desired on screen, we can kind of get an idea of the scale of what we're making. So let's add a size box, and this size box is going to hold our progress bars and our icons, and we're just going to slap this onto our main HUD when we're finished with it. So this section that I want to hold the progress bars is going to be 300 by 200. I'm just going to zoom in a bit. And we want to add a canvas panel inside this size box. And this way we'll be able to kind of lay things out with anchors. So first thing, let's add an image just for a backdrop. And we want to anchor this to full screen and just set all the offsets to 0. And we want the Z order to be -1 to guarantee us that it'll be on the bottom beneath everything else. So first thing we want is a vertical box, kind of on the right side of this, to stack our 3 progress bars. So let's search for vertical box. We're going to anchor it to the right, since it's going to take up this right side here. I'm just gonna change it to this one. If we change the position X to 0 and the alignment of the X to 1, it is now on the right side, and as we resize it, it'll resize accordingly. So I want the size X to be 220, so it's gonna take up the majority of this. This left section is reserved for our 3 icons, letting you know which one's health, which one's stamina, which one's battery. And the offsets are going to be 20, so 20 right here, and I'm going to make the offset top 20 as well. Now inside this vertical box, we need 3 size boxes for our progress bars. So let's start by just adding 1, search for size box, and put it in our vertical box. And we want to check the width and height override, and value I find works for my specific progress bars that I made is 192 by 25 of height. You can't see the 192 right now because it's, I believe it's stretched for the whole thing. But if we take the alignment and we align it to the center, nothing will happen. That's because we need to change this to fill instead of auto. Auto will only request as much room as it needs, and fill will attempt to fill the entire available room, unless you have a width and height override, which, as it says, overrides it. If I were to uncheck the height override, it just collapses to the center. Width override does not, because it's horizontally aligned to the fill, but if we were to do it to the center, it's now collapsed into basically nothingness. So let's recheck width and height, and now we have the correct size. But I don't want this center and center, I want this left and center, just to kind of get it closer to the center of the overall box. Clicking fill is also nice because as we add more, they will evenly distribute vertically, as this is a vertical box. So we don't have to worry about the math that's required to make these all evenly distributed. So let's duplicate this twice. So it's Control-C, vertical box, Control-V. As you can see, it's distributed itself. Choose the vertical box again, and Control-V again. Now we have these 3 size boxes inside a vertical box that will hold our progress bars. So let's actually add one of the progress bars to the first one. So search progress bar, and hover it over the first size box, and it'll automatically fill the entire thing. So here in this progress bar, it does basically what you think it would do. It has this percent, which is a bar ranging from 0 to 1, not 0 to 100. And if we drag it, you can see it updates in real time. This fill color by default is blue. You can change the bar fill type. Left to right is default. You can make it right to left. You can fill from center, top to bottom, or bottom to top. But we are going to make it left to right. Let's rename this progress bar to health bar. And because they're all going to be variables, then we need to know which ones to reference. And I want to change the style of this, since I don't want the default, which is why I had us import an empty and a full. So background image, we can just search for empty. We have HUD progress bar empty, that's what we imported. And if we go to fill image and open this, we can type progress, I forgot what I called it. HUD progress bar full. Click on that. And we can collapse these again. We don't have to change the marquee image because it's not marquee. We see right here, if we check is marquee, it's does that, and it'll never be that in our game, so we don't have to worry about changing it. Now if we adjust the percent here, it is now updated to what our progress bar looks like. The fill color and opacity is still defaulted to blue, so I'm going to change this back to white, just because I'm not a fan of the blue. And now we have a custom progress bar. So let's duplicate this and add it to other size boxes. So Control C, Control V, Control V, make sure you're duplicating them inside the size boxes. And we'll rename these stamina bar and battery bar. Alright, now let's create a vertical box for our icons here. So we'll need a new vertical box, and we're going to add it to our canvas panel here. So we have two vertical boxes under our canvas panel. This one's going to be aligned to the left. So let's select this right here. Offsets for the top and bottom are going to be 20 again for both, so it's equal to the one on the right. And the X size is not going to be 100, but it will be 60. Now we need 3 images right here, and we'll put them inside size boxes. So search for size box, put it in vertical box, and we need to check fill. If we don't have anything for the width and height override and we choose fill, and these are both set to fill, it will obviously fill. It takes command from these alignments, and these width and height override actually override. Speaking of those, we want to make them 25 by 25, which won't be affected until we change the alignment. So if we change them to center, you'll see we now have this 25 by 25 box. But we only want the vertically aligned to be center and the horizontal to be right. So it's just a bit closer to our bars right here. Now let's duplicate this twice. So Command C, or Control C, I mean. Unless you're on a Mac, then it would be Command C. Choose the vertical box and Control V, vertical box, Control V. And they are now aligned with our progress bars. So let's add images to them. So just search for image, drag it onto the first one. This first one is our health bar, so we want the health, or it's called heart. Yeah, heart icon 1, and drag an image into the next 2. And this one here is our stamina icon, and the last one is our battery icon. It's this battery icon right here, not the battery icon we made for our inventory. Sure, that looks good, yeah. So let's add this to our main HUD and see what this looks like. So if we go into our UMD folder, open main HUD, and if we go to user created, it's starting to get a bit big, so we can always just search for it. Progress bars, we have our W progress bars right here, and you just drag it in. Kind of see the size it takes up on our overall screen, and we can anchor it to the lower left. I'm going to change the Y alignment to 1, because if position Y is at 0, I want that to be still in the screen, so 1. And if X is 0, since it's on the left side, it stays normal. I'll just make these position 50 and negative 25, sure. And let's see how this looks in game. So let's hit play. And now we have those 3 bars at the bottom. Could maybe even move them a little farther down. Strategy. I think 0 and 0 might look good. Let's see how that looks. Yeah, I think that looks great. So now we have our 3 icons down there, but they don't have any functionality, and they don't adjust with our health, stamina, or battery. So in our progress bars widget, in our graph, we'll need to reference the player character, but let's create that reference in our main HUD. So once we're in our graph of our main HUD, I deleted the pre-construct, construct, and tick, as we don't need them right now. We just need to create the variable for player ref, and make it of type L1 character, object reference. We need it editable and exposed on spawn, so check those two. And in our L1 character right here, we can just go to our initialize function, it's right here, and we initialize all these things, and you can see when we create the main HUD, we are now going to set our player reference. That's why we're doing it in the main HUD, so it's easier than doing it in every single sub-widget. We can just take it from the main HUD. So let's right-click on our main HUD widget, and we just need to refresh the node, and our player ref shows up here, and that's because we made the variable expose on spawn. So since we're spawning this in, our player ref can now be adjusted, and we can just get a reference to ourself as that player ref. Now in W progress bars, we have to also make a variable for player ref, so player ref, get it as L1 character, object reference, compile and save, and we need to set it in our main HUD. And we do need the event construct right here, and we just have to get W progress bars. It exists right here, and that's just because it's added into our main HUD. And we just can set the player ref as our player ref right here. So the reference just gets passed down the line from our character to our main HUD to our W progress bars. So now in our progress bars, we just need to set our progress bars, I should say. So let's start with the health. So we can just select it, and we have this percent right here. Remember, we need this to be anywhere between 0 and 1. And we'll do that by binding it. So select this bind right here, and we want to create binding. So click that, and we just have created essentially this function with an output, and this output needs to be a number between 0 and 1 to set our progress bar. So to get that, we'll get our player ref, and since this is health, we'll get BPC health, and we just need all 3 variables, the current health, the minimum health, and the maximum health. So to get the current health, which could be a number between 0 and 100, to a value that's between 0 and 1, we just need to divide the current health by the max health, and that makes it now a value between 0 and 1 rather than 0 and 100. This is great because it allows us to change our max health at any time, and our progress bar will not be affected. Although, if you want to change your minimum health, this does change things. This little bit of math here does not work unless the minimum health is 0, which it is, and it will be for most of you, but if anybody does want to change it, this is how you get around this. It's just kind of a foolproof way of setting up your code to do all the math right. So instead of getting the current health directly to divide by max health, we get current health divided by, not divided by, I'm sorry, minus float, our min health, and plug it in like that. Since our min health is 0 at the moment, this doesn't actually do anything, as in this value is equal to our current health, so it doesn't hurt you if your min health is 0. But if it is something else, subtracting the min health from the current health and then dividing it by the max health will then once again give us a value between 0 and 1, and I'll put it into the return value. We just need to repeat this process for the stamina and the battery. So let's grab our stamina progress bar, percent We want to create a new binding. Pull this out. Play ref. And get BPC movement. So we need our max current and min stamina. So we can get our max stamina. Our current. Oh, and our current. I know why our current isn't showing up. We need to go into. We need to open BPC movement. So if you go into content, blueprints, blueprint components, and open BPC movement, we have our max, current, and min right here. We made our current and min private, but I just realized we actually need them to be public, so uncheck private for both of those. Back in our W progress bars, we can now access them. So we'll get the max, current, and min stamina. And let's just do the same bit of code right here. So current stamina minus min stamina divided by our max stamina. That's stamina. Now let's do battery. So select the battery progress bar, percent bind, create binding. And we just need our player ref. We need our BPC flashlight. And we need current battery level, min battery level, and max battery level. Let's get our current minus our min divided by our max. Compile and save, and now all three should be working. Let's actually test it out. So let's hit play, and you can see the stamina and the battery are full, and the health is not. So let's test out the health first. If you remember our buttons 2 and 3 on our keyboard, deplete and add to it. We'll see it also in the top left as it prints strings. So let's hit 2, and you can see in the top left it says 48, and our bar has also depleted. Press 2 more until it's gone. Press 3, and we can just play around with that. Now for stamina, let's just start sprinting around and see if the stamina bar down there updates. And it does. So we're gonna just keep sprinting, and we're gonna stop about halfway. It's gonna wait a few seconds and start refilling. There we go. We're gonna start sprinting again. I'm gonna sprint all the way to 0. Almost there. And 0, we stop sprinting. I can't sprint anymore. Pressing shift. And it should start refilling. There we go. And lastly, battery. If we turn on our battery, we can see at the bottom left and in the top left that our battery is depleting. Once it gets to 20%, it should start fading. There it is, and we are out. And we cannot turn our battery back on. I'm also going to hit 2 a couple more times to take our health away. Now let's pick up some bandages and some batteries. And let's use a battery and look in the bottom left as I use it. And it's replenished our battery. Let's take a health pack, and it's given us 30% of our health. There we go. Alright, so it looks like those now work. We can get rid of the print strings in the upper left. We can go into our BPC movement and find all our print strings. So if we go to find results here, we search for print string. We see we have 2 in here. So one is during the sprint timer. Let's just delete this and plug that back in. Let's double click the other one. This is during our regeneration stamina. Delete this and plug this in. Compile and save. We can do the same in our flashlight. So find results, print string, no results found. Right, I believe we do that in our L1 character, but we'll go back to that. So open BPC health. There's one right there already, but let's go ahead and search for print string, and that's the only one. So we can go ahead and delete it. Now in L1 character, we have a lot of print strings we want to keep, but I know where the one we want to get rid of is in the event graph. We can leave these here since they're a debug, the 2 and 3. But I'm going to get rid of the tick for the flashlight battery level. Oops, well, did not mean to do that. Let's just bring these all up a little bit. All right, so it's a bit more clean now, and we only have the bottom left to tell us what our current percentages are at.